Oh no. Okay, alright. Yes. I'm here, I'm back, and I'm ready to stream something. I'm ready to begin the scratch. Begin the scratch. Yeah. So let's just whoops, wrong thing. Can you see this beauty? Oh yes, you can. Okay, neat. Here we have Scratch. So, what we're gonna do today, what we're doing is we're making 3D in Scratch. We're making a 3D game in Scratch. We're gonna use Turbo Warp for that. I'm gonna enable high quality pen so it would look yeser, and I'm gonna store the project settings just so it'd be ready. Okay. So far we have absolutely nothing. That's an empty script, as you can see. And yeah, what we have to do is we have to I'm not even sure. So what we're gonna do now is I guess let's try to make maybe noise generation or something. Although I'm not exactly sure how to make noise, so yeah, let's ignore noise for now. Let's just ignore noise and let's make a map list which will store our map. Just gonna call it block, or I guess chunk. Yeah, we're just gonna call it map. And so what we have to do first is we have to initiate the map, because in Scratch the list that we currently have, it's empty. It doesn't have anything in it, and we have to fix it because we can't just add stuff to it easily, like we can't write to it as to a normal list. So I have to do that. Kind of works like a Python array, if you ask me. So let's initiate it. Initiate up list. Now I'm gonna have SX, SX, SY, SZ. And those are our sizes of the map. It's size on X coordinate, size on Y coordinate, and size on Z coordinate. Oh, that's very zoomed out. I'm not sure how much do I need to zoom in. There's no one at the stream that can tell me how good the text looks like. I have no idea how well do you see the text, really. Well, if anyone will join, please tell me. Can you see the text? I doubt it. I'm gonna assume that you can see the text well enough. So what we have to do is we have to let's create a few variables. I'm gonna call it world map size X, very long variable name. World map size Y, and world map size Z. Maybe we should use what's that? Nah. Let's use a snake case. Size Z. Okay. So we're gonna do that, and then we're just gonna set those variables to the appropriate things, to the inputs that we have into our function, kind of. So then we're gonna repeat for sx times sy times z, and we're simply gonna add zeros to the map. I guess we should call it fill map with fill map. Yeah, heck it. I'm gonna call it initiate map. Filling ID, and we're just gonna have an ID. And by default, it will be 0. Yes. So let's actually add 0 to it, because if I remember correctly, if we're not gonna pass into the variable, then it will give us nothing, and I just kind of don't want to do that. Although it really doesn't matter, I think. So anyway, actually first we have to delete stuff from the map, because maybe we had a map, and so that would be nice if we had this. Then let's actually try to initialize the map. So I'm gonna initialize the map with the size that is not possible in normal Scratch, but is possible in TurboWarp. So 256 by 256 by like 32, I think. That will give us the map with the size of, yeah, we'll have like 2 million blocks in our map. Filling ID is 0. And as you can see, length of map, if we check it, you can see, there we go. It's 2 million. So pretty big map. So then, let's actually check if it is indeed, yes, it's filled with zeros, that's nice. Then, what we need to do is we need to, let's make a main loop. I guess I'm gonna split stuff into more functions than I usually do, because I feel like it will... actually I don't know. I'm not sure how to organize the project, which is kind of unfortunate, but we'll see what we can do. So I guess I'll have a function that I'll call init, and this function will simply initiate stuff. So we'll have camera position, or I guess player position, because I'm planning to make this as a proper 3D survival game. So yeah, I guess I'm gonna add 0 here, just so it wouldn't bother me. I can delete this. Okay, so initiate map with this size. Cool. Awesome, awesome, awesome. Then what we have to do is we have to really normally I would add generate map. Let's actually generate a map. Yeah. Oh, so I probably should do that. Oh, init, or I don't know, misc. I'm gonna call it misc. And then I'm gonna generate a thing that is related to world, just so it would be easier to find in the block menu, because we're gonna have a lot of functions, obviously. So what we're gonna do is we're gonna world generate land, I guess, and that's it. We don't need any inputs here, or I guess we do. Generate flatland level. No, I don't know, elevation. Elevation. Just gonna call it E. Okay, so elevation will be just the point where we're gonna. It will be our elevation, the map. And I think it's quite easy. So then we're gonna have a world. Again, px, or I guess just x. World. Again, py, or just y. Again, gen z. So we're gonna use these for offsets for our map, and we're gonna use for loops. They're not available in the vanilla Scratch, but they do work in vanilla Scratch, which is quite interesting. So for some reason they were hidden but I do have the access to them, which is quite nice. I'm gonna also use while loops because they're more I'm more familiar with them than with repeat until. Repeat until is just a little bit confusing for me. So yeah, anyway. Repeat gen z for world map size z. Repeat gen y for world map size that, and then same for x. Not that. This. Okay. And so now what we're gonna do is we're gonna shit. Okay, so if it might be more logical to or nah. So if we're gonna make a lot of if statements, so if our position on the z, so z will be height. Yeah, I think we're gonna make z as our height instead of y, but I don't think it really matters a lot. So we're gonna have xy as the normal 2D coordinate and z is height. Yeah, I hope that makes sense. So our array starts with sorry, the counters start with 1 because Scratch uses indices starting from 1 for lists. So yeah, but anyway, so if our gen z is equal to elevation, then we're gonna plot a block, replace item, and then we have to convert thing. To convert the 3 dimensions to 1 dimension, because we obviously have 1-dimensional list here. That's quite easy to do. So yeah, I'm not sure how much sense it makes to do, but I'm gonna add another variable called world map plane size. And plane is just x times y. It will equal to that. That's the whole purpose of this thing. So we wouldn't have to recalculate it each time we plot a block. I think it recalculates it each time. I'm not actually completely sure about that. But anyway, it doesn't really hurt that much, except I guess add another variable, but it really doesn't matter. So we're gonna multiply z. I guess we're gonna start with x then. So we're just gonna add x. Nothing special there. Then we're gonna multiply gen y by map size x, and then we're gonna multiply gen z by the world map size of map plane size, and we're gonna add it to our thing. And here we go, here we have an index. Obviously they're all zeros right now, but really it doesn't matter. Interesting, does this mean that we're starting at, because they're all start at 1, that means we're skipping a few blocks, I think. That's what I realized right now. Because if we're gonna set them to all 1s, they'll equal to this, the output of this will be 3. Never mind, it's not even close to 3, right? That's not nice. We're skipping a lot of blocks there, which is not very good. So I think what we need to do is we need to subtract 1 from the gen y. So we'll get a 1. And then if we're gonna go to move 1 in z, 1 times plane size. Oh, right, we haven't actually set the plane size. Let's try to do it again. And yeah, 65,537. Yeah, that seems to be correct. So yeah, we're gonna roll with that. But we're gonna see if that will give us any issues. But I think it shouldn't give us any errors or something. Because Crash doesn't even know what error is, I think. Let's actually make a special function for setting a block. We're gonna call it world. I'm gonna set block at, I'm just gonna x, y, z. And obviously that will set our block at x, y, and z. Like that. And ID, we need another input, ID. Okay, great. So now, what we're gonna do is we're gonna, if our gen z is equal to elevation, then we're gonna set block at gen x, gen y, gen z, and we're gonna set it to 1. Else we're gonna check. Actually, we're gonna not do it like that, but we're gonna check if our gen z is it is bigger than elevation. So if it's bigger than elevation, then we're just gonna completely ignore it. So I'm gonna make it not bigger than elevation. If it's not bigger than elevation, then we're gonna do the checks. So here, if it's equal to elevation, then we're gonna set it to 1. Otherwise, if else, if the elevation is equal to, I guess if gen z is less than elevation, so it's less than elevation, so suppose we have like 1 is, yeah. Oh, right, if it's less than elevation, but if it's bigger than elevation minus, pick random from 5 to 6, or from 3 to 5, I don't know. Like that, maybe? So if our elevation is less than, sorry, if our pointer for z is less than elevation, but it is bigger than elevation minus that, then we're gonna set another block. And we're gonna set block ID 2, otherwise we're gonna set block ID 3. Yes. Makes sense. Now, what we're gonna do now is we're going to rename this. Isk. Oops. Okay. So let's make a simple raycasting function, and let's actually render something, because right now we don't render anything. That's kind of lame. So let's do just that. So I need a render loop. Render frame. And we're just gonna, render frame. Res. Okay, so Actually, wait, have I? Yes. We need to have it run with a screen refresh, because otherwise, if we're not gonna do that, then we'll lag a lot in TurboWarp when it's compiled, which is not something we want. Okay, so then what we're gonna need is we need to set our position at Y and an X at X to minus 180 plus resolution over divided by 2, because our pen works like that. And we're going to set our pen size to resolution times square root of 2, because then the pen looks fine and we're not gonna have any spaces in between our pixels, kind of virtual pixels, I don't know. Because we're doing, the resolution is kind of fake, because in the resolution here is 480 by 360, but here we're gonna reduce it, so we will be able to render something that won't take us ages to render, especially when we're testing with a very simple raycasting function, which would just step a tiny bit, which is not very efficient. But anyway, so what we're gonna do is we're gonna just repeat. I'm not gonna use for loops here, because there is no need to. I'm gonna have two nested repeat functions. Here we're gonna set x to 240 to plus half of the resolution. And here we're gonna change the x by resolution, and here we're gonna change y by resolution. Oops, by resolution. And then here, here and here, we're going to divide, I think, 480. And we need to divide 480 by resolution, and we need to, I'd say, round it up. And actually, that's for this spot, because this is rendering width, this is rendering our height. Here we go. That's done. Now we need a function that will calculate our pixel. We're gonna call it, it will rend, and we're gonna call it calculate pixel at, we can make it run with screen refresh, and we're gonna have U and V as inputs. So UV, what that means is UV is it's a coordinate, it's the same as XY, but the thing is the U and V will go from, in this instance they will go from -1 to 1, which is very, very nice to have. Anyway, gonna put it right here, gonna put that right there, and gonna recalculate pixel. Gonna put it somewhere right there. In calculate pixel, we're not gonna do much, except we're gonna set color to, and we're gonna do some cool maths here. So I'm gonna create a few variables that will start with an underscore. I'm gonna call it R, G, and B. So this is obviously red, green, and blue, and in this project we're gonna use RGB instead of Scratch's way of, its hue, saturation, and brightness has by HSV, I think it's actually called, not HSB. But yeah, I'm not gonna use that, because we can use RGB values, and that's just much easier to work with, rather than with the brightness and stuff. We have much more control over things, and we can actually mix the colors properly. So, what we're gonna do is we're gonna set R, set G, and set B. I guess we don't need to really B at this point. We're just gonna set R and G. So because those values are from -1 to 1, we're gonna make them from 1 to from 0 to 1, because we don't need negative numbers, we can't use them. So we're gonna multiply these by 255? 55, yes. At 255. We're gonna floor them. So we're gonna round them the closest to the smallest integer. So now, when we have done that, we need to multiply those by 65,536. That's for our red. Lovely. I just hate when that happens. I'm not sure why. Although I have an idea why does it crash, because after I enabled one function in OBS, it starts to crash a lot, which is unfortunate. Although I'm not sure, maybe there is some other problem. Maybe it's my internet problem. I don't know. But anyway, we're going to continue doing the mighty raycasting, the cubes 3D 100% pen, no sprites allowed, I don't know. So anyway, calculate pixel at U and V. So here what we're gonna do is we're gonna actually gonna create another function which will be rend ratio. And so the ratio is simply the ratio 4:3 or 480 by 360, which is the aspect ratio of our Scratch project. And we need this to compensate for the stuff. Yes, although that means that our U coordinate can go even big. It can be even bigger than -1 and 1. So because of that, we're not gonna compensate for anything, and we're just gonna test it. So let's divide X position by 240, and let's divide Y position by 180. And because positions in Scratch go from negative to positive, we don't have to do anything other than that. We can just plop that into here, and it will, in theory, just work. Let's enable turbo mode in the Scratch. I've done that using Shift and just click on the flag. Let's make it when the green flag is clicked. We're gonna make a forever loop, and in the forever loop we're gonna just call render frame and resolution, for example, 2. I'm not gonna erase the frame because that will blink and that will look horrible, so that's why I'm not gonna do that. So let's try that. Let's save the project first, although I do have... Okay, right, I forgot one thing. So we're setting the color, that's good, but we're not actually plotting anything. So to do that, we can pen down here, and when we're changing the Y coordinate, we can pen up. And so we'll get something like this. Gorgeous, isn't it? I think we can... Can I see a... It feels like there is a whitish thing right there in the corner. Let's try to make resolution even smaller. Actually, no, it looks fine. It's just me being weird. But as you can see, it worked flawlessly. It works absolutely perfect. So now that we know that our thing works, let's multiply. Let's compensate for our aspect ratio, because you can see that the thing is not a perfect square. So when we're gonna do that, this RGB to blah 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 function will become weird. It's due to... because it's not how it's gonna work. So as you can see, now I have a perfect square in the center, but we also have some artifacts on the left and the right. But it's fine, doesn't matter. What matters is that our function does work. Great. So, let's clean stuff up, and let's actually make something that can render blocks. First, what I'm gonna do is actually I will do things. Yes. So I'm not sure. I'm not gonna generate flatland just yet. Actually, what I'm gonna do is I'm gonna initiate map. Yeah, list. It's good. But what I'm gonna do is instead of generating flatland, I'm gonna generate just random blocks everywhere, and that will be a pretty good test for anything, if we can even render stuff. So anyway, I'm just gonna have this thing here and this thing here. So ID, it doesn't matter the ID right now, because we don't have the block IDs list where we're gonna write the information about the blocks, like how solid they are, their RG and B channels. That's actually better to split those up. So yeah, we're gonna write that information. Also alpha, so we could make glass or something like that. And yeah, a lot of cool things. Maybe even sounds, probably even sounds. But anyway, so if we're gonna place blocks not every time, obviously. I don't want for that to happen. I'm gonna have pick random, and we have 1 out of 10 chance that we'll plop a block. Let's actually make it even smaller. Let's make it like 1 out of 25 blocks, so we wouldn't get our screen spammed with garbage. So let's call the init function. You saw how slow it was? That means something happened. And what happened was we have placed a lot of blocks in our map. And so, yeah. Finally, we're going to make something cool. First I'm gonna probably move those 2 functions right here, because this I kind of like this when it's like this. I feel like that makes a little bit more sense. So here we have just misc, which is the initialization process and stuff like that. Here we have the world or oriented stuff, and here we have the render. It's split apart because the calculate pixel at blah 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 will be a complicated function. Anyway, so what we're gonna do is we're gonna finally add an actual raycast, and it will be a ray cast ray, and we're gonna have position X, position Y, position Z, and we're gonna have a direction X, direction Y, direction Z, and we have a length limit. Although we're gonna use 1 global length limit, I feel like we don't really need other limits. So yeah, anyway, cast position XYZ and direction XYZ. So this ray will expect that our direction is normalized, so we're not gonna do anything with that, and position is, well, it's position. As I said, this will be a very basic raycast function for now. We're obviously gonna replace it with much quicker raycast function, which will use DDA algorithm. So yeah, I'm gonna create a variable called array_x, array_y, and array_z. Actually, wait. Never mind. Or okay, we're gonna. I don't know how. Okay, we're gonna have those variables. We'll need them later, but not for this raycast function. For DDA algorithm, we'll need those. Although they will be called a little bit differently. It's like array world X, array world Y, etc. So anyway, let's while what do we need? While we're not touching a block and our right, we need ray for this function. We need ray length, which I'll just gonna refer to as ray L because it's quicker. So set ray L to 0, and while array L is less than some constant that we're gonna create, which we'll call rend dist, and we're gonna set the render distance to be equal to. Actually, we need to make that in init. I'm not gonna call init each time, but after we create the world, we can set the const render distance to be the maximum possible distance for our world, which is square root of x times x, y times y, z times z. X, y, y, z, z. And then we're gonna add those up. I'm obviously using Pythagorean theorem. And here we go. Here I have square root. That's the maximum distance that we're gonna have on our map, which is 300 blocks. Now, in here, we're gonna, while length of L, ray length is less than constant render distance, we're gonna do that. But here we're gonna have ray. Oh shit! Hold on. Right, I'm back. Now, what we're gonna do is we're gonna do things. I've forgotten what my. So we're gonna cast array. Yes. So what we have to do is we have to have. I guess ray ID. Just gonna call that it like that. And what we have to do is we have to actually access our position. And so to do that, we're gonna use the same formula as we did here. I'm just gonna copy it. But instead of just x, y, and z right here, we're gonna use direction times length plus position x, which is an offset. There is still no one on the stream, which is a little bit saddening and disappointing. Although I should have probably expected that when I'm making a Scratch stream. I guess it's not as interesting. And it's fine. Guess no one is too interested in flipping ray tracing, technically, in Scratch. And it's real-time ray tracing. Although real-time just means that it's rendered in real time, but anyway. It still is very impressive, okay? It still is. No one... Yes. Anyway, let's continue. So we're just replacing the Z with this new Z. And then we're gonna access the item, this item of map. And it will just get, well, right now nothing because the x and because tx and px is zeros, are zeros. That's why we're getting absolutely nothing. Because this function gives us absolutely nothing. But anyway. Oh, that will be very hard to look at after some point, because we're gonna have much longer functions than we have right here. So, actually what we can do first is we're gonna make an extremely long function. I'm gonna bring those back. And what we have to check is if they're outside the map. To do that, we can, well, it's quite simple. So we have to just check if this is less than 1, because remember, Scratch lists are indexed starting from 1. And then for here, for X, we're gonna check if it's bigger than our map size X, -1, because our lists in Scratch are again 0 indexed. So that's why we have to do this annoying thing. And we're gonna put that in AND, or actually no, into OR, like that. And so then we have to do the exact same thing for each coordinate. And I'm gonna quickly do that. So the X right here, and the Z right, sorry, dy and dz right here. Then the same thing here, dy, dz, and instead of X, we're gonna use Y and Z right here. There we go. Then I'm gonna plop that into another OR function. And as you can see, it's quite large. Now, I don't want to put that where I don't want to put it. So, whoops. I actually cannot see a little bit. I'm gonna zoom out just to put this function into here. So now, if this did happen, then we're gonna set ray ID to -1. That will tell us that we hit the sky, and we can just not continue doing absolutely anything. We can just ignore. And we're gonna stop the script. That way we can exit from the script, obviously. But if that didn't happen, then we're gonna set the block to that. So first we're gonna check if our block is outside the map. If it is, then we're just gonna say, hey, we hit the sky. Otherwise, we're gonna set our block ID to the item from map at the coordinate that we currently have. And if the block ID, the ray ID, I guess, if it's bigger than 0, so if it's not air, then we're gonna also break out, but here we're just gonna break, and we don't have to set the ray ID to something else. And here we go. Actually, here I think we just need how's it called? We just need forever loop. I don't know if we really need a while loop here, because I mean we're casting it just forever, and we're gonna exit from the loop in theory anyway. So I'm just gonna put not in here, so we're gonna repeat it forever. Although I think if I'm gonna leave it like that, it will just work. No. Okay, let's make forever loop then. That's much easier. And of course, what we have to do before I actually start the script is we need to increment our length by some small number because inaccuracies, because we can accidentally overstep into the thing, which will be very not nice. And here we go. So in theory, that's done. In theory. Okay, let's save that. We're not gonna cast anything yet. Or I guess we could. Let's try to actually cast something. So we're gonna set 0 here, we're gonna set 1 here, and we're gonna set 0 here. Oh wait, no, that's our starting position. Let's set it to 128 by 128 by 16. That's exactly the center of our map. Almost exactly, because our map is made out of even amount of blocks. Although we can set it to 127.5 and that will be exact center. And here we can set it to 15.5, I think. And that will give us the correct number, I think. Whatever, it doesn't matter. And here we're gonna set our direction to 0, 1, 0. So we're gonna cast in Y direction. Cast one ray, and what do we get? We get... Hey! We have hit the grass! That's actually pretty cool. I haven't really expected that. But that means that it works, and that's very nice. Then, what we're gonna do? We're gonna save the project because I'm paranoid, and we're gonna create a function that will calculate the length of, well, any vector really. We're gonna call it, we're gonna have category math, and I'm gonna call it vector or length. And we're just gonna say x, y, z, which will be the vector. Okay, so here we're gonna use obviously Pythagorean theorem, because functions in Scratch they cannot return anything. We'll have to create our return thing, and I guess I'm gonna call it math length or something like that. I'm gonna set math length to blah blah blah, and I'm just gonna steal the function from here because we have already made it, and it's not very. Don't want to remake it. Although it is quite a simple function, so it doesn't matter that much. Whoops, I have just deleted the thing. I feel like this is more of a tutorial stream, because I already kind of know what I'm doing. I wanted to remake the Scratch project to make it better, hopefully. Faster, but it might be slower just because we'll have more functionality here. And I am actually interested in making this a complete 3D game with AAA graphics and ray tracing and caustics, of course. Yes, we're gonna make War realistic particle simulation 69 for 20 FPS in Scratch. Just in Scratch. We're gonna make this in flipping Scratch, and we can even set the resolution to 4K, and that will be sick, trust me. That will be absolutely incredible. Trust me, ghosts, because there is no one on the stream. Trust me. It will be sick. It will be new cool game. I don't know any good titles nowadays. They all seem kind of shit, which is rather unfortunate, but I mean, yeah. Okay, so then what we're gonna do is we're going to... What have I made? I have calculated the length. Okay, great. Actually, we can replace this. This blah blah blah. I can replace it with shorter code, which will be, I guess, nicer. At least it wouldn't be that absolutely ginormous. Because those sticks are kind of annoying. They do be getting kind of annoying. So, why did I want to calculate length? Finally, I've got to this point. So the length is needed for the calculating our UV coordinate, because we need it. There is probably some other way of doing this, but I feel like this is the easiest one. Not sure if it's the fastest, but it is the easiest. So I'm gonna roll with it. Also, here we have the opportunity to enter the FOV of our thing. And I'm just gonna make it through a variable because of course I will. Const. Also I misspelled the const in the previous thing. Okay. Const FOV. Or field of view, of course. Const. Here we go. No, it's not misspelled. Okay, const FOV. We're gonna set the FOV to 0.8, I think. Looks more kind of fine. It's a little bit bigger view that we're gonna have, which is nicer. So yeah, the smaller the number, the bigger the FOV we're gonna have. I guess I could make the inverse. Apologies, I yawned. But yeah, I think we could make it in inverse, but doesn't matter. Oh, hey, hello, welcome back. Yeah, I'm doing the stream. I'm doing the Scratch stream wood. Yes, I'm doing the ray tracing, I guess, Minecraft in Scratch. It's the thing that you saw in the CM4's thing. In CM4's channel, in Show Us Your Projects, I've showed the thing. This is I'm remaking it because I feel like it will be... I'm hoping to make it faster and just better code. And better shadows and stuff, because my shadows were nice, but they weren't complete, I feel like. And also my RGB functions were kind of annoying, so kind of wanted to remake it because of that. Because I want to add more flexibility. So right now I'm calculating the actual pixel. I'm the most interesting part. For now I'm using very slow raycasting function, but after a few minutes I'm sure we're gonna use very, very fast DDA algorithm, which stands for... I don't remember what it stands actually for, but it's a fast algorithm to cast rays. Anyway, for now we don't have any rotation math, so I'm just gonna ignore it. And we're gonna cast ray from... we don't actually have the positions of our player, which I'm gonna add right now. I'm gonna call it player X, Y, and player Z. And I'm actually planning on making this a full-on game, a survival game that you will be able to play, because I think that might be fun. So I might even add the chunks, which I'm gonna... that will work even in vanilla Scratch, but really not recommended, but you should be able to run it in Scratch. So I'm gonna compress the chunks and put them in the other list in one line, because you can put infinite amount of information in one line. So yeah, I'm gonna do that. So I'm gonna put our camera, our player at center of the map, which is this coordinate, these coordinates, and I'm gonna leave it right there. Here, what I'm gonna do is I'm gonna divide this by u, const fov, and v, and we're gonna divide that by math length, which is the length of this vector. So we're gonna normalize the vector and cast a ray in that direction. And just gonna make a simple if-else loop. So if the thing is not equal to -1, which is right here, it means if we hit it equals to -1 when we hit the sky, or I guess just went outside the map. So we're gonna do that, and it's array ID. If array ID is not equal to -1, then we can do thing. Also, I've just realized I probably should actually. Yeah, it doesn't matter. I don't need to reset it. So, just gonna make an if loop, or else. Yeah, fuck it. Let's make it in if else. So for now, I'm gonna make sky completely black and other stuff to be, I guess, set color to like return ID times 50. Although I do have just grass in my thing, so it wouldn't really matter. So I think that's it. So let's try to actually launch it. I'm gonna save it first. Okay, we see absolutely nothing. That's not great. Let's try to do that again. Okay, we see absolutely nothing. That's unfortunate. So what the problem might be? Good question. Let's try to add more colors. I'm not sure. Because I am making it one solid color right now, so let's make it like random. Because IDs doesn't matter for now. Okay, absolutely nothing. Let's make it 1 out of 10. Okay, I see absolutely nothing. Oh no. This doesn't work. Oh no. Oh shit. Does it return anything? 10. Ah, actually, wait. What? Does absolutely nothing. Interesting. We are setting the color. Oh, wait. I think I might know what the issue will be. Because we're setting the color, but we're kind of supposed to... Okay, I hate Scratch. A little bit. It's kind of silly. So I'm gonna make it just blue, gradients of blue. Yeah, here we go. Now we have blocks. Those are all blocks in theory, by the way. That's a lot of blue. Wow, let's make it from 0 to 255. No, let's make it from 0 to 16,777, 235, I think it was, or 36. It doesn't matter. But it's 2 to the power of 24, I think. And so we're just gonna make completely random numbers, which we could just plop into here, and that would make our thing look nice and colorful instead of just solid blue. Here we go. Now it looks like random noise. Let's render it in high resolution. Wow, what the fuck? Damn. That does look bad. Why is there like a line here? Okay, maybe we should try with a smaller map first. Just 32 by 32 by 32. We can see absolutely nothing. Which is pretty interesting. What could that be? Do we have anything on the map? Yeah, we do. It's just very sparse. Sparse. Yes. Okay, well, I see absolutely nothing. Oh, it might be because our player is outside the bounds of the map. Whoa. Damn. Something is most certainly wrong. Jesus Christ, what the hell? Huh. I don't think that's how Minecraft works. Hell, what is going on? Yeah, what if we set the ID to like 0? Wow, that looks insane. Let's try to set ready to like 0. What? Okay, that definitely didn't fix absolutely anything. Which does make sense. It shouldn't have. Let's try to render not ID but ray length instead. So we're gonna set that to just this color, and then we're gonna set the brightness too. Let's actually set. Let's use blue. Or actually, no, let's use green color. Green is good. So we're gonna set brightness. And we're gonna invert it, of course. This thing. Yes. Invert it, and then we're gonna have a the thing. Well, sure is green, and sure is incorrect. Damn, what a shame. What could that be? I'm questioning that. That's the very first time when that happens. So we calculate the vector length, then we divide that by... If ID is not equal to -1, and we're gonna calculate... It's weird. Very weird. Let's try to, instead of doing that, do that. Maybe that will help. Probably not, but I mean, who knows? Who knows? Yeah, it didn't help. Okay then. That's interesting, but our thing doesn't work. What if we're gonna set it to just 0? It will be just an empty map. Oh hey, it is actually empty. Let's set a block at the position where we know. So we're looking forward, I think. So we're gonna have to place it at 8, 10, 8. ID 1. Let's try that. What is this? Oh! Right! Okay, I know what the problem is. I know exactly what the problem is. I'm not rounding this. Because we can't access the item in list if we have it when it's a float. We have to floor it. Right, I forgot about that part. Okay, then it must work right now. It must. Okay, at least it doesn't give us complete nonsense. Let's try that. Yes, it worked! Yeah, as you can see, it have fixed it. And what a beautiful look! Those are cubes. Okay, I'm gonna have a button, which will be our button, which will just render our frame in very high resolution. And here we go. Here is a bunch of green cubes. Isn't that incredible? Okay, let's make those cubes colorful. And to do that, we can just do that. Bam! Colorful cubes. As you can see, very nice. The cubes are jagged. Beautiful. If you're gonna do that, they won't be jagged. Or will be less jagged. But it is much slower. Very cool, isn't it? Look at that. Ray casting. That actually looks pretty cool. Okay. We're gonna save that. And I'm going to replace the algorithm with ray matching is faster. You'll see. You'll see this will become very fast. Even like this is nothing. The speed that we have right now is absolutely pathetic. We can increase it by using a proper raycasting algorithm, because essentially what I've done is that's raycasting. That's the simplest raycasting you can make. We're just stepping by 100th. So we're just doing small steps. But what we can do is we can make bigger steps, which will just make more sense to make. Yes. We're gonna use DDA, which will step much more efficiently. So I'm gonna keep this code right there, somewhere right there. And we'll change it a bit because we're gonna have a lot more variables now. So, onto the variables. We're gonna need ray x, ray y, ray z, finally. Ray x, ray y, ray z. And we're gonna floor those. So this will be kind of a world position. Px, py, pz. So we're gonna floor that. Then what we need is we need unit steps. Yes. I'm gonna call it ray unit. Just ray unit. Oh wait, we need the coordinates too. Ray unit x, ray unit y, ray unit z. So I might forget how to actually make the DDA because I'm not actually quite sure how it works. I mean, I understand what it does, but I'm not sure how it actually works. Anyway, I'm just gonna... It will work, hopefully. I just don't quite remember how to make it. So what we need to do to find unit x or unit y, we just need to find absolute of 1 over and each component of our direction. And that will be our units. Then we're gonna need distance, rate distance. This one I'm gonna call this distance. And we're gonna create another variable which we'll call ray length x. Gonna have more proper names. Ray length y, ray length z. And those we will have to, oh, we will also need ray step, which will be just an integer. Oops. I need to make those for each coordinate too. Unfortunately, we can't have vectors in Scratch, which really sucks, but I mean, it's fine. We can just have a fuckload of variables, and all of them are global. Nothing can go wrong in this. Anyway, now we're gonna have if-else statement for each direction. So if direction is bigger than 0, what we're gonna do is we're gonna set ray step x to +1 because our direction is positive, and otherwise we're gonna set it to -1. Then we have to set ray length x to some magic. So I think what we need to do is we need to subtract our floored floored ray position, because yeah, it's floored. We need to subtract it from this one, from just position, I think, and then we need to add 1. And then we're gonna multiply all of that by unit step, which we calculated earlier. Like that. And that's when it's positive. I think, I don't quite remember. What that does is we're calculating our how much we're where we're located in the the cube. I don't know how to describe that. But here we need to just position minus ray x, and we don't need to add 1 for the negative part. So if I haven't done that correctly, then we'll see something very wrong. But if I've done that correctly, we'll see that everything will be absolutely fine. So the same for dy. We're just gonna change the coordinates to y everywhere. ray y. Yes, ray y. Ray y and ray unit y. Like that. Same thing here. Whoops, whoops. And same thing here. And here. Not Z. Y. Y. Here we go. And obviously we need to change those two. So step Y. Okay. Great, so that's done. Now the same for Z component. Ray step Z. Ray length Z. Ray. Oops, ray. Step. Ray length. Ray Z. Ray Z. Ray unit Z. And ray unit Z. And here we need to replace it with PZ. Not that one, that one. And here we go, I think that's correct. Z. Okay, great. So here we have our initiation for our cast. Then we need to set ray distance to... Do I need to say? Yeah, I think, yeah, I need to set it to 0. And then we're gonna make a forever loop. And then we're gonna bring all of that stuff back here. But here we can simplify. We don't need all of that. Because we have our floored positions, which we can use to check if the ray is outside our map. So I'm gonna use ray X, ray Y, and ray Z. Like that. And then same thing here, because our ray X and Y and Z, there will be always integer. We can use it just like that. And here we go. Very nice. So we're gonna leave that part of the code here. We don't need to change anything here, but we do need to add some stuff here, which is the mighty if-else statements. So we need 2 of them nested like this. And what we're gonna check, we are going to check which if ray length X is less than ray length Y. And if ray length X is even so I need to check if the ray length X is the smallest one. So to do that, we're gonna do this. Apparently they're already, oh, they're equal to none. That's very nice. And then same thing here, but we need to check if our ray length Y is less than ray length Z. So if X is the smallest length, then we're gonna change our ray X. Yes, we're gonna change our ray X by ray step X, which, if you remember, is a integer. So that's very nice. Then we're going to change our length X by ray step X, I think. No, wait. This is an integer. And to change our ray length by by ray unit X. And also we need to set our distance to be equal to ray length X. Ray distance. Like that, if I remember correctly. And then the same thing goes for this and this, but obviously we change the coordinates to be Y here. Ray distances stays the same. We're just gonna change this thing. What is it? Ray length. Ray length 1. Y. And ray length Y. Ray unit Y. Ray length. Ray Z. Ray step Z. Ray distance. Ray length X. Ray length Z. Ray length Z. We're going to change it by ray unit Z. Like that. Hopefully. This is correct. But I mean, there is only one way to find out, because this is, I think, completely finished. So let's just try that, and hey, look at that! Would you look at that? It actually worked the very, very first time. And look at how fast it is. Of course, we're using the smallest resolution. Let's render it with 1. Look at how fast it is. And look at that. Would you look at that? It is very quick. This is resolution 1. We can render it in even smaller resolution because we have high quality pen. And we can render it, I'm sure, at 0.1 right now. And as you can see... Okay, that's rather slow. Let's make it maybe 0.25, a quarter. And yeah, you can see the thing slowly does that. And would you look at that? The edges look perfect. And it was fast. That was quick. That was a few seconds per frame. But with resolution 4, which is bad resolution actually, it will be very... That's how fast it is. Also, you can see that our things are kind of smudged, the pixels are kind of smudged, and that's due to us using this kind of approach. If I were to change this and actually plot a pixel, then it's gonna look like that. And in my opinion, this kind of looks better, but it is slower, so I'm gonna do that. And I mean, we're gonna probably render it... Actually, we're gonna render it lower resolutions after we add shadows, reflections, I don't know, maybe refractions if I'll figure out the maths. Such things, such cool things. But anyway, here what we have right now. I'm gonna save that project, and we're going to add rotations. Rotations are kind of pain in the ass. They can be. Because I don't quite remember what do we need. Rotations, so we need for rotations we need sine and cosine, and we need the mighty rotation matrices. In Scratch we don't have matrices, that's why you're gonna have to kind of expand everything. And that kind of sucks. I'm gonna rotate it, split that apart into 4 functions, which will be rotate x individually, rotate y individually, rotate z individually, and then rotate x, y, z. Rotate. That I'm gonna call it math. Oops, I accidentally called it math. I wonder why. Rotate x, and we're gonna have a point x, point y, point z, and then we're obviously gonna have an angle. Or just theta or something like that. I'm gonna call it theta, because most people do call it theta. And I'm gonna call it, I'm gonna have return, and we're gonna have return, which will be rot math rot x, math rot y, math rot z, and that will be our rotated point. And we're gonna rotate around the x-axis here. Okay, so for that we need to rotate around X and Z, I think, axes. Two of those. And so, don't quite remember how's the sine and cosine there. So I'm gonna quickly cheat and create a new window for myself, because I don't quite remember what do we need for the for rotations, because the math is a little bit not memorable. Alright, so what we need is I remember cosine goes first, but I don't remember. I think we need to... Where is it? Okay, yeah. I mean, for a rotation for x, we need to leave x be, and we need to change y and z coordinates. Then we need to change x and z, and blah blah blah. Okay, yeah, we need plus and then minus. Okay, great. So, for that, we need cosine times... for now we're gonna leave it because that will be a, a placeholder. So then we need plus sine of angle times something. Then the same thing but with minus sign in it. And here we go. We're gonna plop that into here. For x we need to change x. Sorry, we're not gonna change x at all. We're gonna leave it be. But we are going to put theta here as angle for sine and cosine. And then for into here we're gonna plot y, z. And here we need to put z and y. So we're gonna put that backwards. Like that. So, okay. Now the same thing goes for y-axis and for z, and for all of them. But for all of them we can just apply them sequentially because we can. So math rotate y. And once again we're gonna have point x, point y, point z. I gotta have a dot right here to separate. And I'm gonna have angle theta. Or theta. Theta. Yep. Change the S. Just gonna repeat that. Gonna set actually we can leave it like that. Just gonna change. So for rotate y we leave yb, but we here we place x. So cosine of theta times px plus sine of theta times pz. Y is left alone, and here we're gonna for z we do cosine of theta times z minus sine of theta times px, like that. So then we're going to create another function for final axes, the mighty z-axis. Z. I'm gonna have px, py, pz, whoops, pz, and then I'm gonna have angle theta. Like that. And so, what we're gonna do there is we're going to leave z be, and we're going to cosine of theta times px plus sine of theta times py. Then for y-axis, we do cosine of theta times py minus sine of theta times px. Here we go. That's done. That was simple, right? Hopefully it works. Probably will. Then what we're going to do is we're going to... Actually, for camera, we don't need to rotate around the y-axis because that will tilt our camera, which is not something we really want. And by tilt, I mean we can fuck up the horizon, which we probably don't want to do. I mean, why would we? So yeah, we're not going to do that, and instead we're just gonna rotate X and then rotate Z. We're going to rotate the At first we're gonna plop u divided by math length cos constant FOV divided by my math length, and that. Already kind of getting tired to speak, but yeah. So that's for x, and then for y, because we have our coordinates in rod x, rod y, rod z, we're gonna plop that into here. Then obviously we need to cast ray from that direction, from rotated direction, and we need two coordinates which will be camera x and camera y. Camera z. Camera rotation z. Or I guess player... gotta say it rod. X. X is up and down rotation, and Z should be left and right rotation. Player, rot, and then we can have Z. Don't need Y. Okay, that was a lot of stuff that we have done, and let's try to rotate just around the z-axis. So we're just gonna rotate on one place. Can I change the angle by 0.1 because I'm afraid that we're gonna... hey. Yep, hello, what's up? Welcome to the stream. Our Shalarasi. Shalarasi, okay. Welcome to the stream. I'm doing the ray tracing something. I'm doing maths in Scratch. That's what I'm doing. And I've, in theory, have implemented the rotation. Hey! Yes, I'm here. Anyway, I'm gonna just... Yes, we rotate! Hooray! Hey. No. Stop, hey. I see you in chat. Am I muted? I'm not. I'm definitely very loud, as the thing tells me. As the OBS tells me. I guess I could say yes. Okay. So anyway, we're gonna continue. I'm fine in the Scratch website. Oh, sorry, I'm in the Scratch website. Yes. What? Okay, let's make faster rotation, and yeah, that looks mighty nice. We can also make rotation around the x-axis. My username is Minecraft767. Guess we could check that person? I don't know. I'm just gonna check, I guess. Oh my goodness. I'm gonna check the account after the stream, or not. Okay, not after the stream, but yeah, I'm gonna check it. Okay. Anyway, I'm gonna check it after I finish at least shadows, I guess. Yeah, I'm gonna finish the shadows and then we can check your account. Is it fine? Hopefully it is. So let's find cosine of rotation Z. And let's... How did you make a good project? I mean, you can skip to the beginning of the stream, or I guess 3 minutes after the beginning of the stream, and you can check because you can see the entire process of making this project. I have shared it. See me? Yeah, I saw your projects. I'm gonna check the your project after I implement the shadows, or I don't know. We're gonna see. But anyway, let's make like 16 degrees offset. up and down? Yes. And here we go. Here is our beautiful randomness. Okay, anyway, what I think we should do is we should change the map to be a flat map. So for that we're just going to generate a flat map. Flat, where is it? Generate flatland, elevation 16. And I'm guessing I'm inside the map. I have the position right here. Although I shouldn't be, or actually no, I should. Okay, here we go. Can definitely see the slowdown because we have map much bigger. Or I don't know actually. No, the map should be 32 by 32 by 32. I'm not sure why is it like that. Anyway, let's change our how we render our blocks to make it good, because I'm a little bit tired of looking at just random colors and stuff like that. So what we have to do is we have to do a lot of stuff, but for now we're just gonna ignore a lot of stuff. We can ignore the normals that we have to calculate and stuff like that, because we can. So anyway, what we're going to do is we're going to create another list, which we're gonna call block data or block info. And that will be our information about the blocks, obviously. And we're gonna have a function that will be add, I'm gonna call it block ID, I guess, like that. Or blocks. Yeah, I'm gonna call it blocks. And I'm gonna say add block. And so the block, I guess because I'm making kind of a survival game, I'm trying to make it kind of a survival game, we're going to have a name for it. Yeah, I guess I'm gonna have a name for a block. So name. I'm going to have a RGB channels? I don't know. What should I do? How should I implement this? So the name is fine. The ID will equal to just the length, it doesn't matter. So the name, let's just for now enter RGB and A channels, which is red, green, blue, and alpha channels that we're gonna use. Then we're gonna add stuff afterwards, I guess. And I guess we're gonna also have not a boolean, because booleans are annoying to deal with. We're gonna have is solid thing, which will be important for our raycaster. So to add block, which is gonna add blocks. It's very easy to do. We're just gonna add name. We're gonna add R, G, B, and A, and is solid checks, and that's it. That's how we're gonna add blocks. Then I'm gonna zoom out and I'm gonna place it somewhere appropriate-ish. I'm gonna have that on top of that. I'm gonna have that somewhere right here. So that's our MISC. I guess that will be our new category. So I'm gonna place it somewhere right here, I assume. Yeah. Also, I probably should get rid of this sine and cosine thingy. Let's clean that up. Let's save it. And so now, what we're gonna do is we're going to upgrade our thing here. And we're gonna check not for if it's 0. Actually, yeah, if it's bigger than 0, we're gonna check for that. It doesn't matter. Because is solid, I mean, we still have to render the block, so I don't think it's a very good thing to just skip the block. So yeah, not gonna skip the block. So set pattern color to ID. No, gonna set it to something new. Which will be our ray ID, which is the ID that the ray returns when you actually hit the block. When we don't, we get a -1. Also, I probably should add this guy. But anyway, so how much variables do we have? 6. Yeah, we have 6 variables here, so we have to multiply it by 6. Multiply this by 6, and we need to add 1. Actually, don't have to, because our starting ID is 1, which is grass. Oh, wait, no. Dilemma. I guess I'm gonna have an air block, or... So I'm gonna subtract ID, because our starting ID is... So they would we're gonna offset, we're just gonna ignore the air altogether, because air is not a block. And we're just gonna have that. Obviously we have 0 ID, let's just try to... Oh, green. Okay, here we go. 1. 1 becomes 0, and we're just gonna add 1 because our arrays are indexed from 1. And here we go. Have the access to block name, but we don't need the name. We actually need the R, G, and B components, which is quite easy. I think I'm gonna just make a very long line. That will be faster rather than doing a lot of functions. Although probably, I don't know. We're testing anyway, so I guess it doesn't matter. Let's actually add the blocks first, and I'm gonna add some blocks. I'm gonna have it in init. Here we go, add block. Probably should have added some comments here, because I have no idea what is this. But okay, anyway, the name here is grass block. Red component will be I think 16 to 155. 16. It will be grass color, but it's a little bit less saturated. We could use hex values. That would be easier because we could... Nah. And then alpha will be equal to 0 because, of course. And then is solid, it will equal to 1 because this is indeed solid. Although I feel like it's a little bit unnecessary to do that, because we can use alpha as the way to determine if the block is solid or not. Or no. Actually, no, never mind. What if we have glass, which will be like solid but still transparent? So yeah, that wouldn't work. Then we add the dirt block, and for that I probably will need to open my nice... Oh, actually we can use better grass color, I think. Nicer, more soft grass color. It will be like 50... 170, 50. That will be a softer grass color, I feel like. It's not as intense, so it wouldn't blind. And then for dirt, I'm gonna pick like this, I don't know, what color. I think this is appropriate grass color. Sorry, dirt color, which will be 128, 75, and I think it was 25 there. That will be our dirt block. And then after that we will add a stone block, or I guess just stone, but it doesn't matter. And for stone we're just gonna have like 128, 128, 28. It's quite easy. And that's it. Those are all the blocks that we're gonna have for now. We're gonna obviously add more parameters, so we'll have to do more stuff. Just gonna do that. Bam. For now, nothing will change if I'll run it. So to actually change it some, as you can see here is the grass block, because our ID is equal to 1. So grass block, but we need in R, G, and B components. So R, G, B. Like that. R, G, B. So to convert it, because those in the block info, I'm guessing they will be always floats, so I don't need to floor them or anything like that. We can just multiply it by 65,536 for a red channel. Then I can multiply it by 256 for a green channel, and not multiply this at all, and we're just gonna do that. So this is how we can convert R, G, and B components into RGB together. That's how we do it. And so then we have to add them up. That's quite easy to do. We just obviously add them up like that. And here we get quite a long line, but as you can see, now we have RGB. Whoops, I've just accidentally done that. But anyway, I'm gonna zoom out a little bit so I could actually place the thing. And here, as you can see, the grass is a little bit... Actually, it might be a little bit too not saturated. Just realized that. Let's make it more saturated, like 230. 50-50. So it wouldn't be too dark. And let's make it more... okay, actually, that will make it brighter, but not... 2020... Wait, sorry, 220. And saturation like 25. So it will be kind of saturated. A lot saturated. And pretty bright. I think that will be a nice color. So we're gonna delete everything from the block info, and then we're gonna reset it again. And here we go. Here is a nicer grass color. Definitely neat. Have absolutely nothing besides that. Really wish we would have some kind of way to determine what the hell is happening. Let's make a flatland, but let's add let's add movement and landscape. For landscape, I'm just gonna randomly change the Z. I think I can just set Z here. And it won't actually change it. Gen Z, and I'm gonna just set Gen Z to Gen Z plus, and we're gonna have like random thing from -1 to 1. So we'll just get some randomness in our boring world. In theory, it will count up still, and we're just gonna have each iteration a little bit offset. Hopefully. Okay, definitely didn't do anything. Incredible. Well, that's just weird. 32, 33, 31, I'm not sure why I didn't do anything. Let's try to do it here then. Oh, Jesus! Okay then. I certainly didn't expect that. What? You know what? I'm gonna leave it like that. That looks absolutely horrible. And that's still a good way to check the map. I'm gonna leave it as is. That's perfect. Amazing. Anyway. Actually, I think I can optimize this. Let's optimize the map plotting function. And to optimize it, we can just set elevation plus what? I think. No, actually. Nah. Optimization is a farce. Not gonna need it anytime soon. So we're just gonna have a nuked map. That's perfect. So let's add movement finally. Let's delete that and let's add a function that will move us. So we're gonna have controls. I'm gonna call it controls. And this will obviously just be controls for the player. Gonna have it right there. For now, we're going to have a constant resolution, but afterwards we're gonna change it to not constant. So in the controls we'll have to make the resolution change. Okay, so if we have pressed, that's not around. If the key W was pressed, WSD is better than arrows, by the way. I'm quite sure that a lot of people, a lot of scratchers use that for some reason. Anyway. Where is the... Oh, I don't... wait, no, I do have positions. Okay. Change player X and player Y. X, Y. Because Z is height, and we're gonna change height using Q and E. Because we cannot have shift in Scratch. Scratch doesn't know what shift is for some reason. Doesn't know what spacebar is, though. Which is curious. Let's add just this will be a temporary, but this will be cam speed. This will be the speed of our camera, because right now we're flying camera. We don't have physics. I feel like we'll add physics very late into the development of this project. So yeah, set constant camera speed to 8.1. Because right now we'll be frame dependent. We're gonna add frame independency afterwards. So set player X, player Y. Sorry, change them by sine and cosine. Even though, yeah. And we're gonna change, gonna use Z as our direction where we're gonna face. Sorry, for angles we're gonna use player rotation Z, because that's the correct one. And we're gonna multiply that by player camera speed. Just like that. So go get a sine and cosine, and then multiply it like that. So gonna do the same for S, except obviously it will be reversed. So just gonna have a minus sign with that. And then for A and D, the easiest way to do it, we're just gonna A, D. We're just gonna, we don't have to have a minus sign there. Because what we're gonna do for A, we can just subtract 90 degrees. Whoops. So we're gonna just subtract 90 degrees from the player rotation Z, and that's how we're gonna do it. That's quite simple. That's the easiest way of doing it. So here's our A and D done. Now let's make camera controls on arrows. For now, we're not gonna have any limitations for our angle, specifically for rotation on X, so our up and down rotations. But we will add them later, because right now I don't want to add them because they're a little bit annoying. Okay, anyway, if up arrow is pressed, actually let's make left and right first, which is quite easy to do. I'm gonna set player rotation Z to be player rotation Z plus Constant camera speed, but we kinda have to multiply it by like 16, I'd say, is a good number, if I remember correctly. And then we're gonna mod 360. Because I don't want to have the angle constantly rise, I want to have angle limited to 360 degrees. Although it probably Scratch internally, it's already been done. Oh, actually, for left arrow we have to subtract that. And for right arrow we have to add that. Okay, so player controls, let's call that, and let's actually try that. And as you can see, we can indeed move. We can't look up and down, but we can move like this. So you can see how horribly messed up the world looks. Awful, awful. What happened? Don't even know how that happened, but it did. Oh, actually I do know how that happened. That's curious. I'm gonna leave it. So now we need up and down. Up arrow, down arrow. And we're gonna set player rotation around X. Axis to be player rotation X. Player rotation X. And we're gonna do... Actually, we can... I think that's it. Yeah, as you can see, we can now rotate. I would probably increase the camera speed by like 0.2. And as you can see, that looks pretty nice. Obviously, we don't have shadows, we don't even have depth, so we have no clue. It just looks like gray color right there. So yeah, we're gonna fix that by, let's just add simplest effect, which is okay, not effect, but let's add the simplest thing called just Z buffer. Sorry, just the depth. So for that, we just have ray distance, and we're gonna const rand dist minus ray distance, and that will give us the number between something and something. That will actually no, we have to divide ray distance by the const rand dist. That will give us the number between 0 and 1, and then we'll have to inverse that, because right now the bigger the distance, the closer the number to 1. But we don't want that. We want the opposite, so we have to 1 minus that, and then we get this. So the closer the things are, the brighter they will be. And so here we'll just multiply it by 100, and we'll get a something like that. So now you can see that there is some depth. Obviously things that are... Oh, I forgot that I can't go down. But obviously the things that are close to us, they'll be extremely bright, even brighter than they're supposed to be. They'll... yeah. And the things that are further away from us, they'll appear darker. That's correct. I can probably just display the brightness to you. Just like that. And here you can see just the brightness without any colors. Sorry, just the distance. Which is pretty nice, if you ask me. So we can go that far away. Yeah, then our maps ends. Okay, nice. That's done. I'm gonna leave it as such. For now, that looks pretty much fine. And we already have 541 blocks in this thing, in this project. Which is pretty cool. How long the stream goes? It's just 1 hour. It's nothing. So yeah, now what we're gonna do is we're going to add sky, because right now that looks a little bit just unpleasant. It's too dark. Let's add sky. Let's add... Okay, for the sky, for a good sky, we need a lot of things, actually. We need some RGB functions, we need some I'd say color shifting, so that the sky, because when it's dark and outside, and this, you've seen sunset, you saw that the sky kind of gets redder the darker it is, so we'll have to somehow implement it. Sorry, not darker, but like reddish color, and sometimes even purple colors and pink, which looks nice, and I would love to implement that. But for that we need quite a lot of functions. So yeah, I guess we'll implement the simplest sky. For the simplest sky, we're just gonna have to check how high our ray is currently. We have ray Z. Currently it's at 11, but we're going to divide that by our maximum. Where is it? Map size X. So we're gonna Z. So we're gonna have a number again between 0 and 1. That's very nice number. So with that, I think we can just multiply it by 100 and we'll get something. Obviously we need to set the color to something like color just 100% blue. Or I guess, let's go with this color. Maybe less saturated, like this. This is the color. And then we're gonna set the brightness to be that. I think that's the correct way. Yeah. So here I have the simplest sky. You can really obviously see that it's a literal sky box. And also for some reason you can see the gradient. Why can you see the gradient so well? Huh. Interesting. Oh, I guess that makes sense, because you can see the gradient is exactly as high as the blocks. So yeah, we can fix that by using... Oh, we need to save our rotated thing. So I'm not sure if we're gonna use more rotations, but we probably will use more rotations. We're gonna reuse the rotation function, so that's why we can't have the mathrot X just like that. I can't use it here. So what I need to do is I need to save the thing. So player view, and I'm just gonna have view X. Player view Y, and player view Z. There we go. I'm gonna save all of that. Player view X, okay, whatever, X, and view Y. Sorry, view Z. And we're gonna save that. And I'm gonna do something that might seem weird, but it's not. That will be used for reflections, probably. For repeated reflections. So we need that. For now I'm gonna plop that right here, so nothing should change. And nothing does change, maybe except speed a tad bit. But anyway, now we have a vector. So we have z vector, which we are using. And what we can do is we can multiply it by the ray distance. That way we get a very accurate vector that will give us a smooth gradient, as you can see. Although it do be like that. Yeah, we have to shift it. Or I guess it goes from -1 to 1. Which is not nice, but it is fixable. Because we can just add 1 and divide it by 2. And just like that, it should fix it. There we go. As you can see, now our sky is like that. It even gets darker, when we get closer to it, which is not quite how it's supposed to work. But I'm just gonna go with it. Yeah. Here we have a sky box. Incredible. Right, I forgot the fact that we need to add player position. We need to do not that, we can leave it as such, but we just have to add the player position. I forgot to include that. Yeah, here we go, now that looks perfectly fine. And as you can see, it doesn't get dark when we approach the sky box. Perfect, let's add more blocks. Let's just add actually let's add up and down movement, and then we'll add more blocks. For up and down movement, it's quite easy to do, because we just have to change one variable, which is just the variable Z. The player Z. We're gonna use Q and E for that. So Q will be up, and E will be down. So change player Z. We can delete that and change player Z. Just like that, and we're gonna change it by the const camera speed. And we have to invert E. And here we go, up and down movement done. Now let's make the map much bigger. I'm really curious how it looks like. So let's make the map 112 by 112 by 128. I'm really curious what we'll get with that. How long is the list of map? We're running this in TurboMap, that's why we can't do that. Okay, it's 33 million blocks. Let's run this. Oh yeah. Oh yes! Jesus Christ! That's a lot of blocks. Let's do this. Let's add just random blocks. Oh wait, the IDs. Oh no. So let's initialize them up. And let's fill it up with garbage. I'm very curious what we'll get. We'll get... Oh my god, can you run faster? Oh, that's a lot of blocks. And you can see how well it runs, and it's mostly because we're using the DDA algorithm. And also we're not going through a lot of empty space. But you can see that we have a lot of blocks here. And it's just amazing. I'm not sure why the blocks are so wide. Actually, no, I know why. It's because I haven't implemented the correct way of brightness. Let's maybe let's do one cool thing called putting this into some power. Let's make it. So if we do that, we'll get closer objects to be apparently just complete zero. But no, what we're gonna do is let's bring it to some power. Let's find logarithm of that number. Let's multiply it by some, by like, what power do we want? Let's 5th power. And then we're gonna expatiate it. So because Scratch doesn't have a way of actually doing we don't have powers in Scratch, we have to use logarithms and exponents to actually do that, but it's the same way. So here we have the power to which we're gonna bring the base to. Not much changed. Let's do that then. That will change probably a lot. Okay, that made it brighter. Whoops. Oh god, someone's reading me. Hold on. Wait a sec. Okay, I'm back. That was my grandma that was calling me. And we're continuing. So, what were we doing? We were doing powers of 5. Very good. I probably should. Let's bring it to quarters, so it's... We're gonna find 4th root of that number. Although I feel like we'll get a very big number. Or not. Oh, hey, that actually looks better. Let's bring it to 10th root. Yeah, that looks better. So yeah, if we bring something to the power of 1/10, we are finding 10th root of number. Here's some math for you. So yeah, here we go. That's how Scratch. That's pretty good. Probably not gonna use the map that big because that's a little bit too big. What happened? My Scratch died. Oh no. What the hell happened? Oh no. Oh wow, that was weird. Oh, wait, because I'm saving the... Oh no, don't save this. Oh no. So yeah, it's trying to save this. It's like... It's 33... Not... Oh my god, what the hell did you save? How much data did you save? Oh no. How much does this weigh? Wait, where is it? Oh no, it's in the different place on my computer. Oh no. Where is it? Oh my god, it weighs 4 megabytes. That's... What if I'm gonna open it as a... okay, whatever. Saved a lot of data. That's pretty nice. Also, why is it still saving on the wrong desktop? I have switched desktops. Stupid computer. Why did you save it there? Shouldn't have done that. But it did. Okay, I'm gonna load from my computer and I'm gonna... Wait, can you see that? No, you can't, thank god. I don't know that it really matters. Probably not gonna comprehend it. Okay, loading project. I'm not sure why am I loading the project that is that. Okay, let's make map that is a little bit not completely insane in the size. Wow, I'm lost. Okay, let's try to generate that once again. I have no clue, where am I? Oh, I'm probably outside the map. I sure am. Yeah, I probably should push the player out if he is trying to exit the world. That would be nice. I'm gonna make this a T, and I'm gonna make R to be reload, kind of. So what I'm gonna do is I'm gonna stop other scripts in Sprite, and then I'm gonna init. That's how I'm gonna do that, because that's smart. And then I could have made this function. Okay, so let's make set player things, rot x, rot y. Sorry, rot z. We don't have rot y. But anyway, and then player x, player y, and player z. Z to be just half of our map. Wouldn't really work with Z though, because so I'm gonna set it to maximum, but for X and Y we can set it to not maximum. So yeah, something like that, and then we're just gonna do R, and I'm absolutely clueless where am I still. Have I the generated map? Work. Elevation 32. Ah, I know why. Oh wait, no, I don't know why. Where am I? What? Wow. So I'm right now moving forward, can you tell? Yeah, we really need textures for all of the stuff. That would be very nice. Very conveniency. Oh, someone joined the stream. Oh! Someone joined my server, and that's... What is he gonna do here? I wonder. He doesn't even know English. Perfect. It's very smart. But anyway, we're going to do something. What do we do, people? If there is anyone still here, what are we gonna do next? Are we gonna do shadows? Are we gonna implement textures? Normals? Are we gonna make normal stuff? Okay, normals, yes. Normals is, are we gonna implement textures or shadows? What are we gonna do for next? If there is anyone on the stream, I'm gonna actually check. Well, there is pretty much no one on the stream, so I'm guessing I'm gonna answer myself. We're going to make What a hard choice. Okay, let's start with simplest. They're both pretty hard actually, and pretty annoying to make. Textures are annoying because I have to make normals for them to calculate the normals of the cubes, although it is much easier than in ray matching. No, it's not, but yeah, whatever. It's easy here, and I don't have to normalize the normals. I guess I'm gonna implement make textures and UV textures. So procedural textures and UV textures, because we can here we can have, because we have our ray position, we can have it yes. By the way, is length X, length Y, length Z, is this... ray step X? Huh. I have... Okay, wait, I'm gonna check one thing. So here's what I have right now. Let's press T and render it in kind of high quality. Or at least higher than we currently have. Here we go. Here's pretty high quality. And let's replace that with player view times ray length Z. I'm curious, will that work? Whoa. Okay, that definitely wouldn't work. And it's unfortunate. Okay. Anyway, that was fun to try. I actually should have looked at the sky, but anyway. Let's implement textures. Let's go to the textures. Textures are fun. Then we're gonna implement... I guess we're gonna implement the normals. The calculation of normals. First, because it should be quite simple to do. Okay. Normals. Let's implement normals. Calculate normals. That will be probably related to math. It's quite simple though. So calculate normals. Point X, point Y, point Z. And we're going to create math norm X, math norm Z. Out of order, but doesn't matter. Norm Y. So gonna calculate the normals. I'm gonna put that into maths category. So right here. And so, to calculate the normal, what we have to do is we have to just do some subtractions and additions. That's literally it. That's how simple it is. It's just amazing how simple it is to create normals. To calculate normals, sorry. So what we have to do first is we have to math norm X. Let's actually just create the... find them in the giant list of variables that we already have. At least the names are descriptive. I could show you the previous project, although it is more done, and it's kind of unfair to show. But anyway. So point X, point Y, point Z. I'm just gonna plop that into here. So, what we have to do first is we have to subtract. And here I have to enter some small number. This let's enter, for example, 10 to the power minus 6 or 7. Yeah, let's go with 6. So yeah, by the way, for those who don't know, that E, that's not an error. Because some people have probably seen that on calculators. That's not an error. That's how calculators show if the number is very big or very small in this instance. So 1, and sometimes you have like this number, right? So that's the number, that's the first number that we have. And then we multiply it, that number by, I guess I can't show you here that. Let's show you here. So we multiply this number by 10 to the power, and the power that we have after the e, because e means exponent. It stands for exponent. And so, for example, in this instance, we're multiplying this number by 10 to the power of minus 6. So, essentially, we're multiplying this number by 10 to the power of 6, and then we're doing it 1 over that number. So that's what it means. Hopefully that's understandable, hopefully that's simple, but I mean, if you're a programmer, then you probably already know that. So next, we do that, then we're gonna have to add to the point x, we're gonna have to add this number, and then we'll subtract the math norm x. So we're gonna do that. You can see on the screen what we're doing. It's very hard to explain. So we're gonna do absolutely the same exact thing for y, except we're gonna subtract from point x this number. From point 1, I'm a little bit tired at this point. So yeah, we're gonna do that, and then we're doing the same thing for our z component. So I subtract first, and then we add to point z, but we subtract from the normal z. Just like that. And yeah, of course, I forgot one small issue. We're not actually checking if the... Not actually checking stuff. Obviously, we need to... Sorry. We need to, obviously, this is the index for our map coordinate. That's our index for map. So we have to plot that into here. But before I do that, I'll just do this thing. So if the block at that position is bigger than 0, if its ID is bigger than 0, that means that it's solid and we're going to calculate the normal for it. Yes, so we're just gonna do that, just gonna split that apart a little bit. I'm doing that using Alt, by the way, just for those who don't know how I'm doing that. And I'm doing this in Turbo Warp. This will work in Turbo Warp. Alt shortcut works in Turbo Warp. You might have like brand batch tools, maybe they also add that, but I'm not sure. Just work in Turbo Warp, really. When you're doing any project in Scratch, just use Turbo Warp. It's definitely much simpler. But for now, I'm gonna continue, and yeah, we have to put it like this, so we have to subtract from the normal x the fact that the thing is negative. And you can see everything on the screen, so I'm not gonna explain that really. But that's how we calculate normals. If some people have seen my rematching project and have entered inside the project, they have seen kind of similar thing. There was a place where I had to calculate the normals to obviously make shadows for the object, and so I've used this thing there. Okay. So in theory, this should calculate normals. So we will have to check that, and to check that, we can do that quite easily. We just have to calculate normals. And we have to put the block into here. And I'm gonna save this and I'm gonna check what I've done in the previous project, because I'm not sure how. But it was trivial to calculate normals before. Okay, I see what I've done. I've calculated intersection point rather than using... Okay, I see. I've made everything so simply. So yeah, I just calculate the intersection points of where we have stopped, where our ray have stopped. Jesus, words are hard, and I've been talking constantly for the past 2 hours, 2.5 hours. So I'm getting a little bit tired. I could make a break, but breaks are a little bit lame, especially when I'm doing such awesome and amazing project. Ray tracing in Scratch. So yeah, just gonna calculate intersection point. So I'm gonna call that ray inter x, ray inter y, and ray inter z. Just like that. Yeah. So let's do that. Ray inter x, ray inter y, and ray inter z. Yeah. Here we go. And so to do that, to calculate all of that, what we have to do is we have to simply just paste that, basically, but for x, y, and z, of course. So player view z, where is it? Player view, here we go, x, and player position x. And here we need to do the same but for y. So player view y times ray distance times player position y. And here we go. That's basically it. That's what we need to calculate the intersection points of our ray, or I guess the collision points, if you can call them that. So we're gonna calculate that each time we cast a ray, because it is useful for our sky and for the actual calculations inside the thing. It's just it's better to do that in here. So inter like this, and here we go. Same thing. Everything is exact same. Then to calculate normals, we have to input the intersection point x, y, and z into x, y, and z components of our inputs of the calculate normals function. We do that, and we get normal x, normal y, and normal z. Hopefully. I'm actually not sure if we will, but hopefully we will. I'm sure we will. Sure, it will be absolutely fine. We're gonna do that only when we have collided the block, because we cannot calculate normals for sky. That doesn't make any sense. And also we would exit the bounding box of our map, which is not nice, or not. We may or may not exit the bounds of our map, which is not very nice. So then we're just gonna set our pen color to I'm gonna move that right here for now, and we're gonna set our pen color to something new, and it will be our normals. Normal x, normal y, and normal z. We're gonna use that as our color. To use that as our color, we have to because they can be either -1 or 1, we'll have to fix that. We'll have to add 1 and then divide by 2. So we're just gonna copy that using Alt shortcut. I'm gonna paste that into here, and here we have numbers between 0 and 1, as we like. And then what we do next is we're oh god. Multiplied by 255. Yes. We might actually do that input it into variables that we have created much earlier. Maybe not much earlier, I don't remember when we have actually created them, but it will be RG and B variables. RG and B variables. I'm sorry if I sound a little bit weirder. It's just that my voice started to die a little bit. That does tend to happen when you talk a lot. So yeah, Just ignore that. So we're going to set RGB components of our as colors. We're gonna interpret normals as colors. We're gonna do that, and then we obviously gonna calculate the actual color, which is quite easy to do. You already remember. 65,536. We're gonna multiply that by R, and then 256. We're gonna multiply that by G, and then we're gonna add them up. Add them all up, and here we get a color. And as you can see, here is something. I have no idea if this is correct or not, but we do see a cyan color. Hopefully, it is the color that we're supposed to see. Let's add another block that will levitate, because we do want to see the normals. So let's just create block at 128, and IDs will be 3, so we're gonna make a stone block basically. I have no idea where this is located, and I don't really have a good way to prove it. Ah, I'm in the void. Pleasant. What a pleasure to be. Okay, maybe let's set it to like 16, because we know where the map is. Or 17, I guess. R. I have no idea what's happening. Yeah, this is painful. Let's make it like 90, so we would see the flippin' ground. What the hell? Why can't I see anything at all? That's painful. I have no idea what's happening. I have no idea what's happening. Where am I? Why am I dying? Oh. Oh, right. That's because everything is the same exact color. That's why it's a little bit hard to comprehend. Okay, let's make map teeny, and let's just not generate anything at all, because that's very hard to understand anything. So here, we're in empty cube. So let's create something at 888 of ID 3. And here we have the cube that is... Wow, that means that it's going mental. Oh my god. Why does it have an alpha channel? That's not supposed to happen. Oh, I have an idea why that happens. That's because we haven't floored the functions. Yeah, we have to floor them. I forgot about that. Unfortunately, no one was here to tell me. The fact that I forgot to floor the RG and B components. Okay, it still has a fucking RGB. An alpha. What in the world is happening? I mean, that looks cool, but that's absolutely wrong. What does that happen? What the fuck is that number? How is that possible? Oh, because we were changing everything. Ah, dang it. Yeah, we need to set the variables, not change them constantly. Here we go. That's more like it. It still is completely gray though. Wait, the fuck? Why is it just gray? Oh, spade. Maybe I forgot. Maybe we need to plus and then minus. No, it doesn't change at all. God dang it. Okay, the first problem that we have. Hooray! I always wanted to have an issue in my code. Because that's so pleasant to have in my code. Maybe let's change it to fucking 5, I don't know. No, it doesn't work. Why do you not calculate the normals? Fuck me. Okay, let's show the things and let's slow down everything. Well, that will take ages. Damn, that's fast. Oh. Wait, the normals are just not changing. How dare you? What the fudge is happening? Why is it not changing at all? What the fuck? Am I wrong about something? What is happening? What is going on? Why is it just this color? Disgusting. That's hard. It's bigger than 0. It is bigger than 0. But it doesn't calculate anything for some reason. For the reasons I don't actually know. Wait, I might know the reason. Scratch is a little bit inaccurate. So let's just subtract like 1 to the power of -5. Let's just subtract the tiny amount from here. I'm sure that will just fix everything. Fuck. But why? But why? Why is this not work? Hmm? I'm actually very confused, but why doesn't it work? I've done the same exact thing I've done before and it doesn't seem to be functioning. I'm making something in real life. Okay. Be right back. Wait, if it's bigger than... If it's equal to 0... No, we need... God dang it. Dang it. Still doesn't work. Shite. Why doesn't it work? It's died. Ah. I remember. I forgot to fucking floor the thing. Ah. I'm forgetting to floor the actual positions. I've already mentioned that we cannot access the position that has a float index. Like, we cannot... That's obvious, but I'm forgetting about this. Dang it. God Dang it. The music is the same for a very long time. Okay, I kind of want to switch the music a little bit. Because, something like this, I don't know. How loud is the music, by the way? No one have told me that, but I'm gonna assume that the music is fine. Yeah, it seems to be absolutely fine. I'm definitely much louder than the music. I'm almost clipping. I'm not sure if it's a good thing or not, but I'm gonna assume that it is. Okay, anyway, let's continue doing this thing. So what we have to do is we have to again floor that. And that would be really much appreciated if I was to kind of delete all of that. And just do that. That's certainly much easier. Okay, so we're just gonna move the air. Yes. Yes. Wait, what? Realized one problem, that I'm not even consistent here. Hold on. Not really consistent with flooring. Because here you can see the position of Y is like that, but there it's like that. Yeah, let's make it consistent. I'm actually not quite sure how to do that, but let's see. Wow, that's louder, that's for sure. I'm not sure how much louder though. Please someone tell me how loud it is. For me it's not that loud. Yeah, let's probably make it quieter. That's 2%, yeah. Let's make it 2%. So it wouldn't be too loud. Although I could change it on somewhere. Hi, I wish I knew how to code shaders probably, so I could make a voxel renderer, lol. I mean, here we go, you can ditch the entire stream by making something in Scratch, and it's technically shaders. If you're gonna translate all of this into shaders, it might work. The thing that you'll have to deal with is that you're probably... I meant that that is possible. Yes. With Shader Toy probably will have to invert the V thing, because here it starts at the bottom in Scratch. The V is -1 right here and +1 right here. So yeah, anyway. Right, I think that's it for the normals. So I'm just gonna pop that right there and just gonna do that. And hopefully it will just work. Hopefully. It'll probably just work, right? I'll just calculate the normals casually. I mean, I've done that a lot of times before, so why can't I do that now? Hey, it worked! Hooray, that works. That's perfect. Ah, a cube. And yeah, those are normals. You can see that the colors are shit. They're usually a little bit prettier colors. But I mean, that's the easiest... Oh, that's the easiest way of doing it. Did I just see a blue speck somewhere where it's not supposed to be? Nah. Okay, but as you can see, it calculated it and... Perfect. Now we have normals. I actually forgot what I wanted to do. Oh, I wanted to make textures, right. I don't really need normals for textures, but for UV mapping I do. So let's make textures. And maybe RGB functions, because this is a little bit annoying. Let's generate a map. Just a flat map. Elevation 32. Oh god, I don't know. It's elevation 8. Let's have a very teeny tiny map. I'm buried now. Oh, I need to R. Oh, look at the shit colors that I have. Probably should disable the normal. I'm gonna put that right there. Now it's nice green color. And yeah. Right. So next thing that I'm gonna do is textures. Where I'm gonna do an RGB functions too. Because currently I don't have any RGB functions like mix RGB, multiply RGB, and cool things like that. Which would be useful to have. Although I could implement them even without functions themselves. Nah, I don't know. So yes, I'm not sure how to actually do that, because before it was quite messy to work with like RGB functions when you had one variable RGB, and I had to mix all of that using that. I could make a list, but lists are slow. At least they're slower, like 10 times slower than variables, which is not pleasant. So I'm probably gonna just deal with variables. A lot of variables. Yeah. So anyway, let's make a text studio. I'm gonna call a function text. And something like calculate texture. Calculate texture at point X, point Y, point Z. That's not point Y. Point Y, point Z. Normal. And X and and Y and Z, and then we're gonna have ID, and that's the ID of our block, of course. Gonna have that, and I'm also gonna add the normals. Text calculate UV map. And we're gonna calculate the UV coordinate, I guess not map, but coordinates. And here we just need px, py, pz, and normal. And x, and y, and z. I could do it in the same function, but I feel like splitting it apart is a little bit better. And someone's ringing me once again, hold on. No, I will not hold on. How dare you? That's such not a nice thing to do. You just left. Are you leaving me? Oh no. Come on, someone just... JK, okay, that's good. Someone just rang me. Sorry, my mother rang me. Come on, you can't do that. still here. Okay, that's good. We're continuing doing the magic. I would never leave the almighty cube. Oh, yes. Yes, okay. So... calculate textures. So what we need for calculating the textures is... I guess text, or... yeah, this will be text. U... text V. And text W. Because we have 3 coordinates, we obviously will have 3 return things. So text, text, text. So to calculate where we are in UV space, we can just simply floor our position like that, and then we can just subtract point X, point Y, and point Z. That's very much it. We don't need anything to calculate the kind of a UV space, kind of. And so now we'll have to fix all of that, because right now we have 3 coordinates, but we want 2 coordinates, and that will go correctly. Because you don't want to have 3D textures. That's a little bit... I mean, I guess you could make, but it's kind of pain to make, so yeah. We're just gonna make if-else. So if our normal x is equal to -1, or I guess let's go with 1. I want to start with positives first. Let's go with, we need the same for normal y and normal z. And so we're fixing for each coordinate, we have to, for each normal we need to fix all of it. So I'm gonna just reuse the code from my previous project, except I'm actually gonna use if-else statements, because before I, for some reason, didn't. And so, okay, text U and text V. I'm gonna use only 2 of them, because we have, obviously, 2 coordinates, U and V, for each texture. We don't have 3 of them. And we're just gonna do some extremely simple math. Okay, so I'm gonna open my previous project, which you unfortunately can't see the code of. But you're gonna see the end result anyway. So if our normal x is positive, then we're going to set u to 1 minus text v. I'm also gonna probably put those right here so I could easily copy them. And then our v coordinate will equal to w. Then, otherwise, if our normal x is negative, then we're gonna use v and w. V and w, like this. Okay, and then for ny, if the ny is positive, then I'm gonna use u and w. Like that. Otherwise, we're gonna invert u. Like that, and still use w. Then for z, we're gonna use, if the z is positive, we're gonna use u and v. U and v, yes. And for the second one, I think we just need to inverse it. Because here, for some reason, I don't have that. That's weird. I guess I need to just invert it. Or... no, actually I can just leave it be. For, if the coordinate is this one, then we can just, I think, leave it alone. We don't even need to check it. But we'll see. So in theory, if we're gonna just calculate the... let's set somewhere, a block somewhere. I hope you can see the code well enough. So gonna set block at like 8, 8, 10. So a little bit above the ground. Oh, wow. I guess I was in the ground then. But anyway, here is the... For now we don't have any lighting, by the way. I won't implement that, but as you can see, just a normal cube. Let's now display our U and V coordinates. And they should go from from 0 to 1. So that should be very, very easy to show. Also, where are my... Oh, for some reason those are here now. Well, it doesn't matter. So calculate normals, and we're just gonna put those here because those are useful for debugging. And we're just going to so we need to calculate textures. Here we go. And that will do the rest of the stuff for us. Calculate texture at intersection point, and normal equal to normal x, normal y, and normal z, and the ID is equal to obvious ID. Then we're gonna calculate the... Gonna move that stuff from here a little bit, right there, because it's a little bit annoying. So now we're gonna replace this code with text u and text v, and here we don't care if you have coded in shader toy. You know that you don't really need this, and that is also not needed because those should go from 0 to 1, and so in theory you should get a very standard picture, very standard one. So I'm gonna have that right there. Do need that, and please work. Okay, something definitely is wrong. Something is definitely too big because it overflows. Okay, this one is definitely bigger than 1. Wow, that's not nice. Okay. So yeah, you can see that something very fun is happening. Damn. Px PyPZ, Px PyPZ. Okay, how I calculated this position was a tad bit harder. Oh, right, I remember why. Yeah, because I have kind of... I'm back. Welcome back. Pod is boiling. Wood. Yes. Good. Trying to calculate UV. Okay, so for some reason I was doing 0.5 and then I was doing times 2. 0.5, that means it's... I'm not sure what that means. But for some reason I've done in the previous project that. I remember that I understood why I've done that, but now I don't. Okay, it still kind of doesn't work. Cool. Amazing. Okay, what do I have here? Interesting. I was doing it the wrong way around. Oh, hey. It feels like I have reflections done already, even though there is no reflections. Damn. Cool. It's supposed to happen. 0.5, what is happening? So position X minus floor position X minus 0.5 and times 2. Let's log those. Let's log this because I'm curious to what what's actually happening. So to do logging, we can just do that. And here we're gonna plop this thing. U, V, and the W. Let's check what is equal to. Why is one of them bigger than 0? That's... what? Some of them probably even bigger than 2. Okay, that's neat. What if we don't need to do any of that? Maybe I just... if I'm not gonna do that? Oh, that fixed it? Kind of? Okay, well, you can see that... okay, I guess... oh wow, that's not very fast. What was that? Oh shit, I'm actually writing to logs all of that time. Jesus. Yeah, that's why it's slow. Oh, but yeah, as you can see, here's kind of a standard picture, although it isn't. It's the wrong way around. Okay, it's incorrect. Something messed up. I guess this project is a little bit different than the previous one somehow. Even though I think I've done everything in the same exact way. Okay, I guess we'll have to do that once again. We'll have to figure out what do we need to do. So V, W, and U. So let's start with the sides. Oh hey, that actually looks correct. It's this code, right? Okay, it's not. Wait, what? What is happening? Yeah, right. I guess if we don't reset it works fine, so I could just UNV, just leave it alone. Yeah, that looks to be correct. Where it does not, what the no? Okay, maybe... wait, what? Okay, let's try again. If else... wait, why did I delete all? Okay, error. So somehow something is different this time. Sure, what is different? I'm thinking that I thought that I was doing everything the same way, but apparently not. The normals are... although the normals were different, so I'm not sure. Interesting. Okay, well, if this is bigger than 0, let's do that. Oh, wait, I was doing equal sign, right? Although, wait, the normals are... okay, that shouldn't have done anything. Does something. Okay, that's... why is it all different? Like, it's so much different from the picture that I have seen. Ah! I figured it out, because I'm not actually checking the W component. That's why it looks so different. Okay, I'll put the W component back, so I'll be able to see that thing. So as you can see, now I have everywhere we have the colors everywhere, on every side. And as you can see on the top, it is the correct picture, like we see in the good old shader toy, if you ever used it. When you put the RNG components to that, it looks like this. On the left you have green, on the right you have, on the bottom right you have red. Here you have the mix of them, and here you have the absence of them. Beautiful. Let's now do that. So let's try to fix the... Oh, also we can go inside the block and it will also show the colors inside the block, which is quite fun. But anyway. Okay, that's our X and Y sides. That's our positive X. Okay, U and W. Just gonna... Trial and error is the best way in my opinion. It's just... Okay, that's definitely not right. Oh wow, that looks not nice. Currently figure out how to write to render texture using CPU to figure out the math lol. Yes. How to write to render texture using the CPU to figure out the math lol. Yeah. Could be like that. Okay, what if just U and V? Okay, it's obviously not U and W. Okay, definitely. Although we do have red. But we're gonna use this color. And I've already used it. But we're gonna use W here. That's purple. Okay. Let's set W to 0. Yeah, maybe we don't need to have W for now. We'll check this. But here we have that. U and V looks like that. Which one is red? Red is this one. Let's try W. We get this. Let's try V. Yeah, I'm just trial and error. I've already said that, but I mean... That's nice. Oh, hey. That's kind of correct, although we do need to flip the Y component. Or wait, not. What the fuck? The W? How did X component became Y? Why is everything... Okay, that's weird. But somehow my Y and X got mixed up. What the fuck? That's counterintuitive, that's for sure. But it doesn't matter, it doesn't matter. Just gonna pretend that didn't happen. Okay, that's incorrect. I guess I need to flip that one. Yeah, that makes sense. Okay, I fixed this first one. Let's now fix for the and Y. Okay, so this one. Oh wait, which side? Okay, this one here. Working with this one. Maybe just U and V. What? So W is up and down. V is something. I don't know. Interesting. Okay, V does nothing, that's for sure. Or maybe it does something. No. Wow. That's incorrect. Why am I getting a gradient? I'm so confused. And that happens sometimes, yeah. For some reason it's yellow. Now let's see. Weird gradient. What? This is the most confusing I've ever been. The most confused I've ever been. Because, it doesn't give me anything. Although, what the hell? So, what is U? Okay, U is brighter at the bottom. My U, oh my goodness. Right. What? Something is most certainly wrong. Because how is my... What is happening? Player Y, player Z, XYZ, 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 UVW, RGB. I'm not sure what is happening, really. Because X and Y, like, what is going on? So let's reset it. Maybe I'm calculating the normals are wrong. I have the cube right here, and the cube. So I'm curious. 9, where will it be? On the right, that makes sense. What about 8? It should go forward if I'm gonna go to like 9. And indeed it did. Then what the hell is going on with the normals? This is the most confused I've ever been, because I really am not sure what is going on with the normal maps. Or at least with the normals. Although I did see that the normals are fine, the normals are correct. It's just that something is not correct. Okay, maybe let's disable the compiler for now. So the project will become like 1,000 times slower. But I will be able to debug in real time, which might be helpful. I'll change the resolution to 8 though. Yeah, you can see how bad it is. Damn, is it really that slow? 16? Yeah, here we go. 16 is better. So gonna have 16 and we'll be able to, in theory, to just do it in real time. Which is what I need. So this is U, this is V. V is absolutely nothing, and this is... Wait. Am I stupid? What? So, somehow, W and U, so the X coordinate... I figured it out. Okay, I see a small issue. We have else statement. God. Now I understand. Oh, I hope you don't hear it. Right. Oh, we're continuing. So I figured out. So because we are setting the... We have an if-else statement. What that means is, if the statement is not... If this is not true, then we will do the other thing. Thing is, our normal can be 0. That's why it doesn't even work. That's why we should probably either add a check or something else. But we're just gonna make a quick check. I think that will be faster rather than splitting it apart into two things. Yeah, we'll have to just check it once. So if it's not equals to, if it's not 0, then we will do something about it. Otherwise, we're gonna ignore it. Here we go. This is the fix. This is the good shit. This is how we fix it. Yeah, I've just forgot about that. So now, everything should... Yes, now you can see that everything is completely different. And in theory, if we'll plop stuff here, we'll see something different. And V does mean something. Doesn't... It's not complete garbage. So V is up and down, and we do need... Sorry, W, and we need U. Bam! Here we go. Easy fix. And let's do the same, but for opposite side. As you can see, here is the good... How good it looks. And also how slow everything is. And let's... so here what we need to do is we need to fix this one. Bam! We have fixed it! Hooray! That just took a few, like, more than 10 minutes. Yeah, unfortunately, I didn't notice the small issue that I had. But anyway, now that I know that I had this issue, I can not bother. So with up and down, it's rather simple. We can just do that and do that, I think. So we can just plop u and v, and for this one we just use u and inverse of u and v. And here we have that. For the bottom we have this. I'm not sure if it's actually correct, but for the top we have this, and it is correct. So bam, it works. Alright. So then we don't really need w here at all, and I don't want to render w. Let's just ignore the b component. And as you can see, that looks like absolute shit, because let's enable the compiler. And oh god, yeah, you can see that with the compiler it is a lot faster. So let's render with resolution 4 as we did before, and as you can see, here's how it looks. Ah, beautiful. Look at that. I feel like this should be also different. I'm not sure. I would love to have like thing that would show X, Y, and Z. Like, pretty nice to have. But anyway, let's render in high resolution so you would see how actually crisp it is. Look at that. Damn, that looks really good. So you can see each block, you can see the things, and those numbers are between 0 and 1. We can put textures on it. We can texturize everything now. Using an actual, like if I really want to, I could just convert Minecraft textures, plop them into here, and use them. But you know what? That's a tiny bit lame, don't you think? So let's use procedural textures. I'm gonna still stick to procedurally generated textures, because they're simply better. Okay? Because we can have infinite resolution. Make Muncie, but only in saves. Yes, in cave saves. What? Caves. 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 Yes, good. Make Minecraft, but only in caves. For caves, I do need to figure out how to make Perlin noise, and actually 3D Perlin noise. Only gray texture. Nah. So, anyway, let's now plot some proper textures. Let's use good textures. For now, we're gonna have just diffusion, so we're gonna have just textures without shadows, without normals. Okay, just without shadows, without any shadows, because we can use normals to calculate shadows too, but only for objects. We can layer stuff. That's what I mean. So anyway, calculate texture at blah 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 blah, and here we can just set color, pen color to RGB. We can work with split RGB from now on, I feel like, because that's a little bit easier. But yeah, we're gonna calculate the texture, and we're gonna get a diffusion. Yeah. So I'm gonna create a few more components, which will be diff x. Oh wait, not x, diff r, diff diff b, no, diff g, and diff b. Consistency. Here we go. So this is this means diffusion R, G, and B. Guess if I was doing snake case, I should continue doing snake case, but I don't care. It's Scratch. There is no rules here. So anyway, what we're gonna do now? Calculate textures. Now we just have to do a lot of ifs here. Also, why are they like in between? I'm gonna have dunder. I'm gonna have 2 underscores here, because it's a little bit annoying that they're like this. Okay. I guess I could just say diff dr. Just want a good name. Diff b. There we go. That looks much prettier, I think. So we're just gonna have db dgdr, dunder db, dunder dg, dunder dr. Which then dunder is double underscore. Anyway, if id is equal to 1, am I alive again? Yeah, my OBS kind of likes to die from time to time, and I'm not sure why. It just likes to die from time to time, so I'm gonna ignore it. Although I will disable the feature that have began to doing that. It might be my VPN doing weird shit though, so I'm gonna disable VPN for now. So right, let's continue. Let's create a random, pseudo-random noise. So to generate pseudo noise, we're gonna have like RGB, or I guess also text, and it will be just R. I guess also in square brackets. Get noise at X, Y, Z. And we don't need any other inputs besides just X, Y, Z. So this will be, as I said, just completely. It's very, very simple noise function. So what we need for that? Well, we multiply X, Y, and Z by some random number. For example, that. Okay? Good. Gotcha. For example, this number. Why not? We can. And for example, this number. Now, what we're gonna do is this is a dot product. Here we go. It's dot product of normal vector, of our position vector, and random vector. So calculate dot product, plop it into sine function, just like that, and multiply by another completely random number defined by my keyboard. Good number, and the bigger the better, so we're gonna multiply it by this. We could even just multiply it by tens of thousands, so we could get a floating point precision errors. That would be nice, but that would cause some glitches, so not gonna do that. And then we can just do mod function, and that would normalize our function to be between 0 and 1. And here we go. That's our random, pseudo-random noise function. Theoretically, it should perfectly work. Perfectly good. So just plop that stuff into here. We could make a fake text string effect if we would divide the px_pypz by some value, then flooring this value, the components, and then multiplying it back by 16 by some value, sorry, and then we would get kind of a pixelated effect, a mosaic effect, which would be cool. That's how I've done that in my previous thing, but I'm not gonna do that just yet. So yeah, here we go. Here we have noise, and I actually just realized that we don't have any RGB functions, but we don't actually need any of them, because what we have is we have this. Like that. Hell, do you? Okay. So this is R. What is this? Okay, here we go. R, G, and B, like this. So we start from 2. And what we have to do is we have to just this is noise. It goes from 0 to 1. What we're going to do is we're going to hell, I wish we had a clamp function. That would be very useful. But unfortunately we'll have to clamp ourselves. So what we're gonna do is we're gonna add some number. So we're gonna get the fuck. Well, so we're going to add some number to it. Let's actually calculate first. Oh, we're gonna get 0. But let's wow, that's, well, you can see, I guess, the function working, or what is happening. Damn, that looks beautiful. And very, very messed up. Why is that? It's actually, I'm not sure. Oh, RGB, okay. Huh. What the hell is going on here? Yeah, I don't know, I'm not gonna bother. But anyway, what I have to do is I have to add some number to it. Some music is saying words on the background, and that's not very nice of it. But anyway, we're gonna do that, and if this number is bigger than 1, I guess we're gonna do that, and then we're gonna check if this number is bigger than 1. Then we're gonna just multiply it by 1. We don't have to do that because that's how we can convert the boolean. And it will become 1 by itself. But if the number is less than 1, 0.00001, because I don't want to have like less than. Actually, okay, we can have. I know a smart trick. We can just do if it's not equals to, if it's not bigger than 1, because then it will work correctly. But anyway, if it's not that, but then we're gonna do that. Words are extremely hard, I'm starting to die. But anyway, we have now normalized thing. Yes? Now what we gonna do? Words are hard. So we're going to set RG and B. DR, DG, and DB. Epic music. Really not fitting. So we're gonna multiply the RG and B components of our texture, of our block, sorry, by the noise. Just like that. And so in theory, what we should get is a beautiful texture. And yeah, for now we're gonna set it to DR, like that. Okay, that's sadly not what I wanted. Very far away from what I wanted, but I know the problem. The issue is we have to floor it. And also we have to multiply it by 255, which I forgot to do. Actually, I don't need to. Yeah, because we're multiplying, but I have to floor it. So yeah, for some reason when you don't floor it, it will look like this. Which is weird. But anyway, here we go. Yeah, you can see where we don't know the actual texture for the block, it will look like this. But otherwise it will look like this. Let's I just pressed reset, by the way. because I'm used to R button as to like render, and I'm used to previous project. But yeah, you can see that it's very not random looking. But you know how to fix that? Well, there is a rather easy fix to all of that. We can see the repeating pattern. That's problematic, that sure is. So to fix that, what we can do is we can just simply pixelate it. When we pixelate it, it will look 1,000 times better. So let's do that. Let's do just that. Because we have just noise function, we can divide each component by some number. For example, let's have 16 by 16 pixels. Oh, 16 by 16 by 16. The texture. Let's floor it. And then let's multiply it by 16. Once again. Just like that. And so, we're gonna put the position X, position Y, and position Z into here. And we're gonna plop it back into here. And so in theory, what we will get is something like absolutely nothing. Damn, what a shame. Oh, wait, we need to multiply it first. And then divide, I think. Multiply, floor, divide. I think that's how we do it. Yeah, here we go. And here we have 16 by 16 by 16 for the entirety of map. That's... yeah. Probably should fix that. But it is quite easy to do. We just have to use U and V. And for Z we're gonna use... oh wait, actually it does look like this for the... wait. Ah, strange. Is that really 16 by 16? I can't believe that now. It looks like shit. It's not 16 pixels. What about 32? Congrats, you made CGI. Yes. Okay, that does look better. Although I do feel like the grass texture is a little bit... oh, you can see how... oh wow, the pattern. Jesus. Wow. You can really see that it's repeating. Okay, I'm not gonna use those textures. I'm not gonna use UVW. I'm gonna use PXY. Because then... there will be no pattern. At least it will be... you won't be able to see it. Like here. There is no pattern that you can clearly see. Perfect. So I'm gonna make the noise much less noticeable. I've just pressed R again. Whatever. But here we have that. Maybe. Okay. You know, I have an idea. What if I will square that number? And then gonna add like 5. I'm just curious. I'm gonna try that out. Oh, Jesus Christ. That's even sharper. Maybe I need a square root. Maybe I could just divide it by 2. So by 4, and so I need to add... whoops. 7, 5. Is my capturing still going? Yeah, it still is. Oh, hey, look at that. That's much nicer grass that you can see now. Yeah, that's a much better looking grass. Let's... Jesus, there is so much code. Let's reduce the resolution. Or, yes, it will increase the resolution. So that we will be able to see the texture a little bit better. Would you look at that? That does look like a nice... That's a much nicer texture. That actually looks a lot like Minecraft texture now, which is good. Would we be able to add like PBR textures? I'm curious. Because PBR is purely visual. How would I do that though? Yeah, I have no clue. I can't even imagine how complicated that would make the project. But anyway, here I have a simple grass texture. And let's make some... yeah, sure. So 10... no, let's go with 12, 11, 10, and 9. And we'll start from 1, 2, 3. We don't have 4 for now, so I'm not gonna add it just yet. And because testing stuff, we're gonna just... Okay, so here we go. As you can see, there's buggy textures right there. Because we don't have, they don't set any color. They don't even reset it. So that's why this is happening. Let's save the project, by the way. Right. Now let's add another texture, but really this is very simple because can't we just like that was so complicated. Control C, Control V. Wow. Here we go. That's how textures work. Although stone do be looking kind of whack. But you can see that it looks perfectly fine, except I don't like how sharp the stone is. 8 let's divide it by 8. So the range would be less. And 1/8. And let's subtract 1. Okay, 875. 875. That's how much we need to make it look great. Here we go. Yeah, that's much less sharp, as you can see, which is kind of nicer, I feel like. I don't know. I think this is nicer. Let's maybe make them somewhat different. I'm gonna do that. And it should, in theory, make the dirt. Yeah, like that. Although I don't know if this is better or not. But yeah, anyway, this works pretty good, I think. And we technically have textures that are infinitely good. Kind of infinitely. Because they're using pseudo-random noise. Also, what we could do is we could kind of blend in, I think. We could make a blending between blocks. By that I mean we could add blending for grass and dirt blocks. To me, if I would make it flexible, that would make the project quite slow, I think. If I would make it hard-coded, then it would make project fine. I don't know. It doesn't matter. Looks fine. So yeah, what do people think about, for now, just the diffusion? We don't even have shadows, but it's so easy to add them. At least the very simple. Let's actually, I'm saying shadows are easy to add. Let's add shadows. Let's just add shadows. So for what do we need for shadows? Well, we need to cast another ray. Cool. I'm gonna have a few variables which will control if we want shadows, and also we'll have to like kind of get rid of the shadows. Or actually, yeah, we'll have to kind of do some cool maths for shadows. We're gonna have effect shadows. So this will just enable and disable shadows. That's useful if we want to just check the diffusion. So what color the block is without the shadows. So we're gonna have a check if shadow effect shadows equals to 1. We're gonna set shadows to 1 because we want shadows. We're gonna have shadows to 1. And what we're gonna do is we're gonna cast another ray. Oh, by the way, what we need is we need to save the ray. Enter dist. We need to save the distance because we'll have to compare the previous distance of the normal ray and other distance. We'll have to compare some stuff. Or actually, no, we don't. No, we don't need to. Yeah, we don't actually need to save anything. Hold on, let me delete the useless stuff. Okay, so what we have to do is we have to cast another ray. Cast another ray from the position intersection x intersection y intersection z, and the direction is equal to negative direction of the light, the opposite direction to light. We don't have light, and I made this too. Good for you. Very nice. So yeah, what we have to do is we have to create light vector. Yeah. So I'm gonna just call it world sun x, world sun y, world sun z. So we're gonna have that, and then we're gonna plop that into through a bunch of things in a pot, fried them, and cooked the crap out of them on low setting. Should have used, yes. Whoa. And how does that taste? So we're gonna cast, as I said, we're gonna have cast the ray. Not that bad. That's good. We're gonna cast a not as bad as I expected. That's good to hear. So anyway, here we're casting a ray from intersection position, so the position where our ray have collided with the surface, and then we're casting another ray. Yeah, we're casting a ray from that direction, from that position in direction that is opposite to the sun vector. And then after we do that, we have to check. Okay. Is the return ID is it not 1? Also, I just realized I could have started IDs from 0, but 1. Yeah, whatever. So, if our ID, no, the block that we have collided, if we have, yeah, we're checking if we have collided, and if we did, that means that we will add a shadow. So to add a shadow, we'll do that quite simply. We'll have another thing here, and that will be constant, ambient. We need ambient. And ambient will be just a one value. I don't think we need RGB. So const ambient, and that will be simply ambient. Obviously, you know what ambient is. We're gonna set it to like that will be easier to work with if I'm gonna do that way. So let's ambient will be equal to 20. Well, 21 to 255, so it will equal to this number. I'm gonna have that nearby, so I will need them. So then we're gonna set our DX, Dunder DR, Dunder DG, and etc. to be equal to themselves, but multiplied by the ambient. And we're gonna multiply it by ambient. Ambient, where is ambient? Here we go, here it is. And we're just gonna multiply it by ambient, so it will become darker. Just like that. And so I think that's it. We don't have sun vector, that's what I've realized now. So what we need to do is we need to add a sun vector. It has to be normalized, but it's quite easy to do. Sun. So we just have to calculate the length of the vector length, and we'll just divide it. Math length. That's not what I wanted. That's not what I wanted. No. Here we go. Max math length, and then we're just gonna divide it by sun. Sun X, sun Y, and sun Z. Just like that. Vector length of that. So we're gonna normalize the vector. That's what we're doing right now. And so here, we're gonna have like 2 to -2, so that our sun vector will be pointing down. Actually, maybe -4, and like here we'll have 3, so it will be kind of on the angle. So let's see if this works. Okay, that. You can see that there is a little bit of an issue, but you can see that there is kind of shadow right there. Yeah, I forgot to, again, we have to floor it. I keep forgetting about that. But yeah, you can essentially, I've already kind of spoiled what we're gonna see. Oh wow, that's a little bit too dark. A little bit too dark. Let's have constant ambient to like 30. But yeah, here is very, very hard shadows. So how do we make shadows less hard? You can see that the shadows are a little bit... Yeah, I'm gonna render in high resolution so you would be able to really see how it looks. So yeah, you can see pretty harsh shadow. Not very nice. So we're gonna fix that. To fix that, we can do some cool maths. So yeah, we're gonna grab ray distance, and we're gonna like divide it by some number. Here I have ray distance. I'm gonna divide it by like, let's set, so we're using R as some temporary constant. So gonna set ray distance divided by like 16 or some number like that. So yeah, divided by 16 ray distance, and that will be the distance of our shadow ray. Divided by 16. Then we're gonna do some cool maths on it, and by cool maths I mean we're gonna find the power. So let's bring it to like fourth power, I'd say. And do something like that. I don't remember if this is what I want. Don't quite remember. But yeah, I will assume that it is. And so the thing is, this number can get very big. So to prevent that, we actually have to limit it. And you already saw how I clamped the variable before, so I'm just not gonna really explain it. Here we go. I fix. Now we have a clamped variable. Very easy. I'm gonna plop that right into here. We're gonna do that, and then in theory we're gonna get something nice and good. Yes. And then we can I guess add it with ambient, and let's try to, I'm not actually sure how to do next thing. I guess let's try adding it with ambient and then finding an average between those two. Let's see how that will turn out to be. Maybe that will look nice. But here we're gonna replace const ambient with R, which will be our calculated value for shadow. And shadows became even harder, which is not exactly what I wanted. Let's try to find an inverse of that. Maybe that will help. Oh, yeah, here we go. Now you can see that the shadows are better. They're much less harsh. We can have power, second power, maybe 10th power. And you can see that it becomes lighter. Although not very realistic, it's like it's just became lighter. I should probably make an inverse, like right here. Oh wait, no. Okay, so this is correct. Although it is very small, I'm assuming. Oh yeah, you can see that here is much more. You can see the effect quite nicely here. So yeah, here's a very cool looking shadow. I feel like so let's make ambient to like 40, because I feel like the ambient is a little bit 60? Because I feel like the ambient is a little bit, yeah. But here, as you can see, here is kind of a nice shadow. We have created shadows, peeps. That's a very weird fucking music that I have on the background right now. Let's have something. I don't know what. This. Sure. Okay, so also let's try to using higher power. What if we're gonna use higher power than we currently have? I'm curious. Okay, fourth power makes it much darker, but we can use square root. Oh, and you can see that it's a lot lighter now. What if we're gonna use just the R component? I'm curious. So here's just how the R component looks like, and here's how the constant ambient looks like. And then when we mix those, we're getting something like that. Although, why mix them? Let's multiply them. They're all in the like... Yeah, that's much better. Well, okay, maybe not much better, but now the shadows can get... Yeah, it's more correct. And yeah, this is pretty much kind of the influence, I feel like. Oof. Yeah, I like this a little bit more. Although the shadows can't get not as realistic, I feel like. Yeah, let's find average for this. Let's find average between two of those. There we go. That looks kind of better. Except here it looks very dark. I guess maybe it's realistic. So yeah, that's what we've got now. You can see the shadows are kind of nice. And I think we could enable kind of a cool effect. If we're not gonna calculate any texture, so we're gonna use just white texture, then we'll be able to see just the applied shadows, which should be interesting. So let's try just that. We're gonna remove that part of the code, and we're gonna plop that part of the code right here. And so what I'm gonna do next is I'm gonna set those things to 255, 255, 255. So essentially it will be just white color. And oh wow, that happened quickly. What will we get? Oh. Huh, interesting. Okay, but yeah, I know why it happened, because we have to reset it each time. Hey, and here we go. Here you can see how the shadows are applied. And as you can see, here we have the shadow. Pretty cool, right? Pretty cool, right? Let's also add another block below. I wanted to do that, but I forgot to do it, seems like. So I'm gonna add block at this, also 3 R. Oh. And here we go. Oh yeah, that looks pretty darn cool, not gonna lie. So you can see, it's a nice looking shadow. And so, yeah, it's pretty smooth transition. I've actually expected it to be much worse. I'm not sure if it will actually fade till the point where we'll no longer be able to see it. But yeah. Also, what we could do is we could do some cool thing. I think we could make shadows a little bit smoother, I think, but I've never tried that actually. So I don't know about that. So here we go. Let's try to make smoother shadows. And so what that means is we have to add 2 more variables. I think. Yeah, let's try to, yes, let's try to, do some cool thing. So, actually, I'm not even sure how to make smoother shadows. Do we need to... fuck it, let's try it. Let's try to do it. Or not. That's a dilemma. But yeah, what I want to do is I kind of want to offset. And I'm not sure what to offset. Am I supposed to offset the direction of the ray, or am I supposed to... I'm guessing direction? Nah, fuck it. We're gonna make normal maps now. Normals. So, right now, looks pretty good, right? Looks pretty, yes. But you can see that we're kind of still missing some details here. Like, you can see it's not nice looking. Not particularly nice looking, yeah? Let's fix that. Because, like, you can see here it's supposed to be, like, maybe here it's supposed to be a little bit brighter than here. So, yeah. Let's add normals. So we just need to find a dot product between two vectors, the vector of normal and the sun vector. We just have to find the dot product. Rather easy to do. Dot products are very simple. Cross products are very not simple. So here we go. Now we have a dot product. Very good. This value will be from -1 to 1. Yeah, it will be from -1 to 1. And so we don't need to that means that we have to normalize it. And we'll do that after we it will also be affect shadows, obviously. So we're gonna set R, because we don't need R anymore. We can set R to this value, so to the dot product, and then we will normalize it. R. Sorry, not normalize, but clamp it, because it's kind of normalized. It's in some way. No, it's not, but yeah, you get the point. So if the R is less than ambient, if it's less than ambient, then we're gonna multiply it by ambient. Otherwise, if it's not smaller than ambient, then we're gonna multiply it by itself. Just like that. Nice and easy. So now this number is... It's not clam, actually. Yes, it is. So we're gonna use that. And then we're just gonna apply it to the thing, and I think it will just be done. And here we go. As you can see, it looks much better. Although the shadow, here we can see absolutely nothing, which is interesting. And yeah, I know why it is. That makes sense. Let's multiply it by 1. It's less than ambient. Oh yeah, here we go. As you can see, it fixed. So yeah, if it's less than ambient, then we're just gonna multiply it by fucking 1. It's fine. If it's less than 0. If it's less than... Yeah, if it's less than 0. So if it's negative, then we're gonna multiply it by 1, I think. No? Because that wouldn't look particularly nice. Yeah, it looks fine. So if it's less than 0, then we're gonna set it to 1. If it's not less than 0, then we're gonna set it to itself. I do have a feeling that if I'm gonna rotate the sun, it will look very different. It will look buggy, if you will. Actually, the shadows are also... Or maybe it won't. Damn, that's a hard question. So if it's kind of close to 0, it can get below the ambient, which is not logical. Thing is, it will get as dark as constant. Damn. Hard. Math is hard. So ambient is equal to this number. Good. Okay, yeah, if it's less than this number, then we're gonna set it to 1. If it's not less than this number, then we're gonna set it to R. Yeah, that makes sense, I think. So we wouldn't get something like... I don't know, let's try to rotate the sun. Oh, you can actually hear the whistle. So rotate that, oops, that, and guess it. The world sun, do that. Oh my god, there's so much variables. Mathrot X, Mathrot, like that, and angle, and yeah. So let's rotate it by just 1 degree each time, and let's see what we'll get. Like right here. Okay, that's... yeah, that looks perfect. Wow, beautiful. Okay, yeah, that's certainly not how it works. Shit. And it's very annoying. I've expected that it would be pretty annoying. I guess I need to not multiply it, but mix it. So yeah, I do need to compare it with if it's less than something, then I'm gonna set it to 0. It's not less than 0, we're gonna set it to itself, and then we're gonna mix it maybe. That means we need to multiply it by 255. Yeah, I'm really not sure how to implement this part more correctly, because right now what we're getting is kind of silly. Because I don't want to have places where it's like... no, it still would make it darker, like overall, because nothing is supposed to be darker than ambient. Like, that doesn't make sense. That's not supposed to happen. But here it is possible. Ambient will raise the brightness, but still. Oof. Wow, okay, yeah, that makes sense why I'm not using mixing. Because mixing just mixes white into it, and that just desaturates everything. Okay, so how do I do that? Can someone give me a suggestion? How do I plot that? Because that's... what the fuck is that? Okay, oh, I have an idea. Oh, right, I remember that previously, how I previously made this. And why can't I just do that the same way now? Right, so... let's calculate first R. We're gonna calculate the shadows, and then we're gonna calculate G separately. Gonna do that separately, and they both gonna be won't be able to. Fuck it, whatever. Like that, something like this. Okay, very good. And so then, what we're gonna do at the end is we're gonna add those together and then find average of those. So in theory, that should make better shadows. Whoops. And that shouldn't become darker than it's like... It's not supposed to become too dark, that's what I'm saying. Oh hey, it did become a lot lighter. And now... Oh, fuck me. It doesn't work. God. Shadows are hard. Did you know that? Fuck. And also it became lighter. Okay, maybe we're supposed to pick the lightest value. Yeah, let's pick the lightest one and put it into B. Why not? If I is bigger than B, then we're gonna make R. Plus, and we're just gonna do otherwise thing. We're gonna multiply by that, like this, and here we go. That works. That will work flawlessly, I'm sure. That's nothing that can go wrong. Perfect. Fuck. What is this? Why is this place lighter? Is this shadow lighter? Why is it so obviously switching? God damn it, those stupid shadows. Okay, fuck the normals. No one likes them anyway, so yeah. Oh wow, that's so hard. I'm exhausted. So I probably will just stop stream right here. Yes. Da. Oh, I know. I have an idea actually. We need to find which is the largest. Is the constant ambient larger than R? If it is, then we're gonna multiply that by R. Whoops. And then otherwise, it's not. Then we're gonna return a constant ambient. This is, by the way, faster and easier than if-else statements. That's why I'm using it. And also kind of, yeah. So let's try that. Okay, well, the shadow definitely doesn't look scuffed. Because it gets layered on top, it can't be scuffed. Like, it can't become brighter if it's not bigger than 0, but it's impossible in the way I've programmed it. Which is good. So, right. I'm gonna save this. Now, let's make cool thing called cool thing. Sorry, I'm dying. Sounds of me dying. So we're gonna do that. Check here too, because that makes sense. Although it can become negative. Oh, no, it can't. Because if it's less than 0, then it will just become... number. Ah, please just work. That became a lot darker. Fuck. Fuck. Okay, I certainly need to do something to make it not extraordinary dark. Oops. Okay, how do I implement... Wait, what am I doing here? That's the wrong variable. I'm supposed to use G instead of R here. It still will be dark. Yeah. And it still will... wait, no, no. No. It still will be dark, though. At least everything will be very dark. Fuck. It's still not smooth. What the fuck? Okay, anyway. That was a good stream. We're gonna fix that in the next stream. That will be at some point. Yeah. So, anyway. Everyone who watched, who joined, which was Dabble, XYZ Gaming, some other person. Yes, and Cubic. Also, thanks for Cubic for joining in. So yeah, that was a very good stream. That was a very nice stream. We have made kind of ray tracing, a very basic one. We have successfully made shadows and then fucked them up. Although if I will do that, they will look absolutely fine. So I'm gonna actually render that just so you can see that it actually is pretty good. So I'm gonna render that. Why is it so dark? Okay, hold on, let me make a good render. So yeah, here we render a beautiful graphics, 32-bit, 32. Yeah, it looks fine. Like here, it looks pretty fine, I think. Although we didn't add normals, unfortunately. I mean the shadows for the objects themselves, so they would look better and you could understand how the object looks like. So yeah, we're gonna add that in the next stream, but for now, thanks everyone for joining in. I wish you a good night. For me, it's night at least. And yeah, see ya.